Did you know that DevOps has become a critical practice for organizations seeking to improve their software development and deployment processes? Well, according to a survey conducted by Statista, the global DevOps market is expected to reach 18 billion by 2023, growing at a compound annual growth rate of 19% from 2018 to 2023. In recent years, the demand for DevOps professionals has skyrocketed due to the increased adoption of agile methodologies and the need for faster and more efficient software delivery. As companies strive to stay competitive in today's digital landscape, they are turning to DevOps to streamline their development and operations workflow. So, at Simplilearn, we understand the importance of keeping up with the latest trends and acquiring the necessary skills in DevOps. And that's why we are excited to announce a new video on DevOps Advanced Full Course. In this comprehensive video, we will dive deep into the world of DevOps, covering essential concepts and advanced techniques. The course begins with an introduction to DevOps and its fundamental principles. You will learn how DevOps bridges the gap between development and operations team, enabling seamless collaboration and continuous delivery. We will explore popular DevOps tools and technologies like Docker, Kubernetes, and Jenkins, providing you with hands on demonstrations and real world examples. You will also discover the various career opportunities available in the DevOps field and the skills required to excel as a DevOps engineer. By the end of this video, you will have a solid understanding of DevOps principles, methodologies, and tools, empowering you to drive innovation and deliver high quality software solutions. So don't miss out on this exciting opportunity to level up your DevOps skills. Make sure to subscribe to our YouTube channel and hit the bell icon to stay updated with the latest content from Simplilearn. So let's embark on this transformative DevOps journey together. Get ready for the DevOps Advanced Full Course. But before that, if you're planning to learn about DevOps in a more detailed form and want to square your skills with industry standards, then Simplilearn's Caltech postgraduate program in DevOps can be the right choice for you. This DevOps course, designed in collaboration with Caltech CTME, is a professional development option that has blended learning combined with live online DevOps certification classes with interactive labs that will give you hands-on experience. So, in this course, you will learn how to formalize and document development processes and create a self-documenting system. DevOps certification course will also cover advanced tools like Puppet, SourceStack, and Ansible that help self-governance and automation management at scale. So don't hold yourself. Check out the course link in the description. Also, to support you and boost your confidence, here's a success story of one of our learners that will help you gain insights over your career trajectory. Do watch it.
Hey there, my name is Manuel Canelon.
And I'm Rafael Canelon. We're actually brothers and we live here in Alberta, Canada.
We do a lot of things together. And this time, we decided to take a course in DevOps from Simplilearn.
The course proved to be very beneficial for both our careers.
Yeah, I got a promotion after the course.
And I got hired with a new company.
I'm actually a mechanical engineering graduate, and I've been working at my company for the last 4 years. In 2020, I came to know that my company was starting the hiring process for a DevOps infrastructure team. At the time, I was working as an implementation specialist, and my colleagues recommended I take a course in DevOps if I wanted to be part of the team. So I started doing my research, and then he came to me saying that he was also looking for a DevOps course.
Yeah, funny enough, I actually found the course through Instagram. But my situation was slightly different. I had been working as a geomatics field technician for about 4 years, but I wanted to change my career into something that involved more programming and automation. So when I came across with this course, I said, you know what, let's take it.
And Caltech's name was definitely a deciding factor. In July 2021, we got our certifications, and I immediately posted that on my LinkedIn profile.
Coincidentally, in November of that same year, we got the good news, and I got hired as a GIS developer, which has allowed me to do way more programming, which is what I wanted to do.
Around that time, I got promoted to the DevOps infrastructure team and saw a 21% salary hike. The overall course was awesome, But the part that I enjoyed the most was the Docker certification training.
You know what? I also really enjoyed the Docker certification training. I think they were brothers after all.
Yeah, the experience was amazing, and being able to study together was definitely very nice.
Yeah, it brought us back to those good old days when we were going to school together.
Now, what is the purpose of Jenkins here? Now, Jenkins is normally a kind of a CI tool which we use for performing the build automations and the test cases automation there. It's one of the open source tool which is available there, and one of the most popular CI tool also available into the market. Now, this tool makes it easier for the developers to integrate the changes to the project here. So we can easily integrate the changes, and whatever the modifications we want to manage, we will be able to do that with the help of Jenkins. Now, Jenkins also achieves the continuous integration with the help of couple of plugins. Each and every tool which you want to integrate have its own plugins which is available there. For example, you want to integrate Maven, we have a Maven plugin in Jenkins which you can install, you can configure. In that case, you will be able to use the Maven there. Now, you can deploy the Maven to build tool onto the Jenkins server, and then you can prepare or you can configure any number of Maven jobs in case of Jenkins. So what exactly the Maven or the Jenkins really do is, the Maven when integrates with Jenkins through the particular plugin, so you can able to automate the builds. Because for automation the build you require some integration with the Maven, and that integration is what we are getting from the Maven plugin. So in Jenkins you have to install the Maven plugin, and once the plugin is installed, so what you can do is that you can proceed with the configurations, you can proceed with the setup, and this particular plugin can help you to build out some of the Java based projects which is available there in the Git repositories. And once that is done, you will be able to go ahead and you will be able to process a complete integration of Maven within Jenkins. Right, so let's see that how we can go for the integration. Now I have already installed the Maven onto the Linux virtual machine which we are using. So using the apt utility or using the yum utility, you can actually download the Jenkins package and the Maven package onto the server, onto the virtual machine. And now I'm going to proceed further with the plugin installation and the configuration of a Maven project. So I have a GitHub repository which is having a Maven project, Maven source code and the Mavenized test cases over there. So let's log into the Jenkins and see that how it works. So this is the Jenkins interface which we have over here. Now in this one, what we can do is that we can create some Maven jobs over here, and once those jobs are created, we will be able to do a custom build onto this Jenkins. So first of all, we have to install the particular plugin here. For that, we have to go to the Manage Jenkins. In Manage Jenkins, you have the Manage Plugins option there. So you have to click on that. Now here you will be having different tabs like updates, available, installed, advanced. All these different tabs are available there. So what you can do is that you can click on the available one. When you go to the available tab, so what will happen that here you can actually put up that what exactly plugin you want to fetch here. So I can put up plugin called Maven. Now you can see that the very first one, the Maven integration tool, is available. So I'm going to select that particular plugin and click on download now and install after restart. Now once that is done, so what will happen that the plugin will be downloaded, but in order to reflect the changes we have to do a couple of restart. Now for that you don't have to go to the virtual machine. You have the option here itself that will allow you to do the restart over here when you click on this button. So you check this option and say that restart Jenkins when the installation is done. So what will happen that the installation will be automatically attempted whenever the particular plugin installation is completed here. So you just have to refresh the page again, and you will be able to see that the particular Jenkins is being processed as such here. Right, so you can see that the screen is coming up that Jenkins is restarting. So it will take a couple of 5 to 6 seconds to do the restart and the login screen to come up again over there. You can do the refresh also if you feel. Automatically it will be reloaded once the Jenkins is ready, but sometimes we have to refresh it so that we can get the screen over there. So once the login is done, so my Maven integration is done. So next thing which I will be doing is that I will be creating a Maven related project. So I'm going to put the admin user and the password. So whatever the user and password you have created, so you are going to put that so that you will be able to log into the Jenkins portal. Now this is the Jenkins which is available here. So all you have to do is that you have to click on create a new job or new item. So both the option is pretty much same only. So here you will be able to see a Maven project here. So I'm going to select like Maven build. That's the name which I'm going to give here, and the Maven project I'm going to select here and then press OK. Now here you will be providing the first of all the repository from which you will be checking out the source code. Now I can have a discard old builds over here. So if I feel that I want to have like a log rotation, so all the previous builds should be deleted. So I'm just saying that dates to keep build should be 10 over here, and the number of builds which I need to keep over here is 20. You can adjust these settings according to your requirement, but over here we are doing a kind of configurations which we are trying to do a lot of configurations and settings here. So these are the particular settings which we are looking forward as such over here. So now we are going to have the log rotation here. So we can have it like how many days we want to keep and how many number of builds we want to keep here. So both the values we are providing over here. And then now I'm going to put the git integration here, like the repo URL. So I have this repository here in which I have the Java source code and some particular unit test cases, and all. I also have the particular source code, and it's kind of a Maven project. So that's what I'm trying to clone over here with the help of this plugin. So this plugin will download this repository, it will clone it onto the Jenkins server, and then depending on our integration with Maven, the Maven build will be triggered here. So now I'm going to process with the Maven here. So you can see here that it's saying that Jenkins needs to know that where the Maven is installed, because that Maven version it needs to configure, it needs to process on that part. So I'll just do the save over here, and or I can click on this tool configuration. So I'll just save or do the apply, click on this tool configuration here. Now here you have the options like where you can have the JDK installation, but what happens that since Jenkins is running there, so JDK is automatically installed. So in the tools configuration you don't have to put the JDK configuration, but at least for the Maven configurations you have to provide that where exactly the Maven is available there. So I'm just saying that Maven 3 I want to process, and the latest Maven Apache web server I want to configure here. So I just want to have I just want to save this setting so that it will be automatically download the latest version Apache 3.6.3 version there, and that same should be utilized over here in this case. Now I'm just going to the Maven build configuration here and click on the configure part. So these git repository is available here, and in the build step it automatically builds up that what Maven environment you want to select. So you see that previously, since I did not configure my Maven environment, so it was throwing an error. But once I have configured that I have to download it during the build process or before the build, that utility should be downloaded. So instead of doing the physical installation of Maven on the server, what I have chosen over here is that I have selected the particular version, like I have selected that particular 3.6.3 version should be installed for the Maven purposes over here. Now once that is done, I'm going to put the particular steps over here. You can have it like clean install, you can have clean compile test, clean test, or test alone you can give. It's just a part of the setup or the goals which you want to configure here. It by default says that pom.xml file is the current one in the current directory you need to refer. You need to pick on that one. What it's up to you only that how you want to configure and how you want to process as such these information. So according to your requirement, you can say that okay, I just want to go for these particular goals, and you can say like save over here. The particular configuration will be saved. Now you can just click on the build now, and you will be able to see that the first of all the git clone will happen, and then the desired Maven executable will be the build tool will be configured, and according to that it will be processed here. So you can see here that the Maven is getting downloaded, it's getting configured here, And once it's configured, because I have explained over there that 3.6.3 version I have to select, so that specific version will be configured and will be picked up over here. Now even if you don't have the Maven installed on the physical machine on which the Jenkins is running, still you will be able to do the processing using this particular component here. So you can see here that we have some particular test cases executed, and in the end we are able to get a particular artifacts also there. Since I did not call upon the package or install goal, that's the reason why the particular artifacts was not generated, war file or jar file, whatever the packaging mode is available at POM level. But still what happens that my test cases do gets executed, and that's what I have got over here in this case. So this is a kind of a mechanism where we feel that how we can configure a Git repository. Once the Git repository is configured, you are going to integrate the Maven plugin. In the Maven plugin, you are going to configure in the tools configuration that this and so version I want to configure to run my build. And once that is done, after that you just have to trigger the build and click on the build now option, and once that is done, you will be able to get a particular full-fledged build or compilation happened onto the Jenkins. And this log will give you the complete details that what are the different steps which has happened on this one.
So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system, and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then, typically in your traditional environment, then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software, but probably doesn't have all the development software. And certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say, for instance, you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that's using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get a image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 colon 80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it name my so this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment, and we'll put in the image name, which is Ubuntu, and -bin -bash, and it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state, it's what's known as in an exit state. So here we go. And there's my Docker, it's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container. So what we're going to do in this session is we're going to go through what Docker and Docker container is and why you'd want to use it. We'll then break out what are the characteristics and structure of a Docker Swarm environment. And then finally, we'll go through and do a demo using actual code in the command line interface to actually run and build out the main functions and commands that you would use for a Docker Swarm environment. So with that said, let's get started. So Docker is a tool that we actually use to help automate applications in our environment so that we have a consistent way that we're actually building and testing and validating codes that's being created. Think of it as a virtualization, but much more sophisticated and efficient way of doing virtualization. The thing that you have that's a huge advantage when you're working with Docker is that it's a very lightweight software package. It allows you to have all of the tools needed for actually running the code without having to have the significant overhead that you would normally have with virtualization. So one of the characteristics you have with Docker is that you can actually run multiple Docker environments in the same host environment. And for you to be able to do this, we had to figure out how this would actually run. And so to actually do this, we actually do what's called a Docker Swarm. And a Docker Swarm is an environment where you can actually have multiple Docker images running on the same host operating system. So you can have running in each of those Docker containers different solutions. So let's dig into what a Docker Swarm is. So a Docker Swarm is essentially a tool that allows you to very easily create and schedule multiple Docker nodes. So really 2 or more Docker nodes. And you can have quite a large number of Docker nodes in a single swarm. Each node itself is actually a Docker daemon, and that daemon is able to then interact with the Docker API and have all the benefits of being a full Docker environment. One of the other advantages you have is that each Docker container within the swarm can then be deployed and managed but as a node in that entire clustered environment. So what we have here is a breakdown of the 5 key elements within a Docker environment. You have the Docker container, you have the daemon, the Docker images, and the Docker client and Docker registry. So the Docker daemon itself is what does all the work interacting with the actual host operating system to be able to manage the Docker containers. So if we look here we have set up an environment where we have 3 Docker containers being run with Docker. And what we want to be able to do is be able to interact with the environment, because what would happen if we actually have something change in our environment? So if we have the environment set up as a Docker swarm and one of our containers fails, what we're able to do is use the swarm to be able to correct that failure. So the Docker Swarm Manager is able to come in and reschedule containers. And as you would imagine, the actual Swarm node has full backups and full redundancy for any kind of failures that would happen. And we would do all of this work through command line interface. So let's go through some of the features that you have within the actual Docker Swarm itself. So a key feature for Docker Swarm is that it is fully decentralized, which means that it makes it very easy for teams to be able to access and manage the environment. As you would expect as well, is that the communication that happens between the manager and client nodes within the swarm is highly secure. And of course, this is really just a fundamental that you should have for any kind of solution, but it is good to know that Docker Swarm has that built in. There is also auto load balancing within your environment, and you can actually script that into how you write out and structure your swarm environment. And that load balancing then also allows you to then convert that swarm environment into a highly scalable infrastructure. And then rollback task allows you to be able to roll back environments to previous safe environments. So if, say, something does get pushed out and something breaks, you're able to immediately roll back into a safe environment. So each of the containers are pushed out and are controlled using services, and they actually happen to be REST services, which make it very easy for you to be able to integrate within your environment. And each of the different services contains a group of containers of the same image. Now, by having this structure, it allows you to be able to scale your application appropriate to the demands on your service. So if you have a service that needs to have a significantly larger number of services for it to run, you can actually scale that appropriately, and that can be either geo or demand based. One of the requirements for setting up a Docker Swarm is you must have at least one node deployed. So the way that the architecture is set up is that you have a manager node and a client node, and there must be one of each for the entire environment to be able to work effectively. So, here we are just jumping ahead of ourselves a little bit. We have 2 types of nodes in a Docker Swarm. We have the manager node and we have the worker node, which is the client that does the actual execution of the tasks. The manager node, very similar to other systems that we've talked about on Simplilearn, allows you to actually control and manage the actual tasks that are being executed by the worker nodes. And the worker nodes, as you can imagine, then actually execute the instructions that the manager are sending out to it. So here we have a situation where we can illustrate what would happen with a manager node sending out commands to different worker nodes. The manager is fully aware of the status of the entire swarm environment at all times. This is because of the two-way secure communication that's going from the manager to the worker environment. The workers, as you'd expect, are accepting tasks that are being sent from the manager. So if the manager sends out a task saying that you need to be running as a MySQL environment, then the worker node will then convert to a MySQL environment. And all of these environments are scripted and controlled by you as the manager. The actual worker nodes themselves actually have a client agent, and that client will then communicate all different states of the infrastructure back to the manager, so that any time the manager node is in full control of the entire swarm. The manager is the controller of this environment, and so you always want to be able to ensure that the manager has full access to all of the work that's happening within the swarm, and this allows you as the manager to be able to control your swarm and very quickly be able to react to any changes without having to rely on manual installations of software and hardware. And as we covered earlier on, there is a REST API that uses the communication over HTTP from the manager to the worker node. It's interesting to note that it is a REST API, because if you wanted to, you could actually integrate that API into custom applications and even then create automated Docker images to be created on demand from third-party solutions that you may want to create. So one of the things that's a big advantage with having a swarm is that once you've actually created the swarm, any of the services that you create can be accessed by any node of the same cluster. One of the things you do have to do, though, is you have to specify what container image that you're going to use when you're creating a new service. And you can do that either through a centralized Docker Hub environment or through your own private Docker Hub environment. One of the things that's interesting is that you can set up commands and services to be either global or replicated. A global service will allow you to run a service consistently on every node within the swarm, whereas a replicated service will only push out functionality and tasks to specific worker nodes within a swarm. So you may be asking yourself, hey, isn't a service and task the same thing? No, they're kind of not in the Docker world. And the difference is a service is a description of a task for the state, whereas the actual task is the work that needs to get done. And that's the differentiator here. So what you can do as a Docker user is you actually create services, and then you can then define when you want them to start as tasks. Now, what's interesting is that when you do assign a task to a node, that same task cannot be assigned to another node. Also, what's interesting is that you can actually have multiple managers within a Docker Swarm environment. If you do, however, go down this path, you have to elect one manager to be the primary manager and the other managers to be secondary managers. In many ways, those secondary managers are really similar in concept to worker nodes, in which they have the capability of a manager, but they are dependent on that single primary manager to be able to provide the right instructions and for services and tasks to the entire Swarm environment. So if we kind of recap some of these, we have a command line interface, which allows us to create and connect via APIs. And that those APIs that we connect to in our Swarm environment allows us to do orchestration via tasks and services. The task allocation allows us to allocate work to tasks via their IP address, which allows them to execute them on the work. And then the worker nodes themselves have to connect to the manager node to be able to check for when tasks come in so that they are keeping a consistent communication back and forth across the entire swarm. And then the final stage is to actually execute the tasks that have been assigned from the manager node to the worker node so that you have a successful execution of the solution you're looking to build. All right, so with that said, let's go ahead and we're going to do a demo. So we're going to go ahead and do a demo and showing how you can run Docker Swarm. For this, you'll need to have both a virtual environment running your manager and your working environment. So here we have our worker and here we have our manager. So we're just going to open up terminal window and we're going to go into the manager for terminal window. So the following command here is used to initialize Docker Swarm. We're just going to type this in. So sudo docker swarm init, and we put the IP address for the network we're connecting to. And we'll put in our password. And here we have now connected. And this is our manager node. And what we want to be able to highlight is the specific token which identifies the Docker Swarm environment. And this is our token right here. So we're going to copy that, because we'll need to use that for our worker environment. So here we are in the worker environment, and we'll use the token that we just copied as a way to be able to connect to the manager and connect to the Docker Swarm environment. And so sudo, we'll paste in the Docker Swarm and we'll join that. And now here we shows that we have joined the Swarm environment as a worker. And now that we're in the manager, we can actually show that we actually have that worker in the environment. So there's docker node ls to list out all of the items in that environment. Sorry, we actually did that in the wrong area. So we're on the right, sudo docker node ls to list out all the nodes in the swarm. And there you are. You see we've actually connected the worker to the manager node, and both are active, and the manager is the leader and the worker VirtualBox is in the swarm. Okay, we're going to go ahead and create a new service. So Docker Swarm create, and we're going to just change the name to Hello World for the new service, and we're going to use the Alpine image from docker.com. Takes just a moment for it to run. There we go. And there we go. Services converged. So what we have now is a new service that has been created. Let's go ahead and we'll list out the services. And here we have our new Hello World service. And we go ahead and check the Docker containers, and we're going to do Docker PS, and here's our Alpine. It's running the latest image, and that's the Docker container ID. And we can see that it was just updated. And so what we're going to do is use the same command in the worker node and make sure everything is working over there. So go over to our worker, paste that in. So what we see here is there is no image or container created because it's not in the worker node, it would be in the manager node. So we can go ahead and create the new service. And we're going to make the mode global, and that way the service is available across all of the swarm. So we're just going to execute that work. Takes a moment. And there we are. Done. Work has been completed. And we have the two different IDs, which shows the two different services are running. And if we go back to the worker mode and we run sudo.docker ps again, and there we are. Now we see that we have the Hello World new virtual environment has been added with the image of Alpine. And we also have the new token ID for that. If we want to kill a node from the swarm, we can use the following command, which is sudo docker swarm leave -- force. And that will force the node to leave the swarm. So in this session, what we're going to do is we're going to go through what Docker is, and then by extension, what Docker Compose is and how it improves the performance of Docker, what the benefits of working with Docker Compose is. We are going to cover as well what the difference between Docker Compose and Docker Swarm is, because the two products are similar, but they have two different types of job. And at the end of this presentation, we'll take you through some basic commands that allow you to get up and running working with Docker and Docker Compose. Finally, after this presentation, we'll do a brief demo that allows you to get up and running using some of these commands to do your own Docker Compose environment. So let's get started with Docker Compose. So first of all, we have to kind of cover what Docker is. So Docker has come as an evolution of technologies that started with virtual machines, VM machine. And a VM machine allowed you to run a complete operating system and its environment on your own computer, in your own operating system, without it interfering. The problem is that it was very heavy and complex, and in contrast, Docker is a much more lightweight and more flexible environment that you can automate with scripts. So we have to remember that the container itself is just software, and it has dependencies that run within that application that are managed by Docker. So if we have a look at the way Docker is broken out, first of all, we have the Docker image, and we have the Docker image created by a Docker file. And the Docker file is a text-based script. And that text file within Docker file actually has all the commands that allow you to run the appropriate technologies within the Docker image. So the Docker image allows you to be able to have a wide group of people consistently run the same environment. And if you want to be able to share that Docker image effectively, you would do so by uploading to Docker Hub. And Docker Hub can be available either publicly through the public Docker Hub website, or you can actually set up your own private enterprise Docker Hub to share your own images across your own network. And then from Docker Hub, people can then pull their own Docker image and build new containers that are consistent on the original Docker container that you created. So it's a great way of being able to have your entire team scale up easily and effectively. So one of the questions that will come up though is, what if you want to use two containers in a single service? And an example of this might be like a web server that is using a database, but the database may be in one container and the web server may be in another container, which is very typical for your own web and database infrastructure. So very similar scenario, but how would you do this with Docker? So by using just Docker itself, it's actually very difficult to do this. You can do it, but it's just very time consuming and just not a very good use of your productivity. But with Docker Compose, you can actually do the whole process quite quickly and easily, and hence the reason why we have Docker Compose, to allow you to have 2 or more Docker containers running in the same environment, being able to communicate as if they were running in a production environment. So let's dig into what Docker Compose is. So let's consider a scenario that you'd have today. So Myntra is a fashion website similar to Amazon, and you'd go to Myntra with your web browser, and on that website you would go through a number of activities such as logging into your account, browsing a catalog, you'd have your checkout application server, and you go through the typical process of building out an application. Behind each of these services are different products, such as you'd have an account database, you'd have a product database, different checkout processes, and these would all be run behind the scenes. And each of these can be considered a microservice. So the more microservices you build into your environment, the more complexity you're adding, and the more of value it would be to have each of these services in their own container. But as a developer, you want to be able to jump from one container to another container, so your login account can then be passed onto your product catalog and then be able to move through the whole process. So the environment that you would see today would be more like what we're showing right now, where you'd have your server and your database, and you may have a server running on Apache Tomcat or SQL Server. You'd have different databases, and you'd want to be able to have each of those in their own containerized environment. So the way that Docker Compose runs is that it works as a single service. So you have the Docker Compose running multiple containers, but the perception is of a single service running. The thing that's great though is that each of those containers will run in isolation, but they can interact with each other. So unlike a normal Docker environment where you have multiple Docker images running completely in isolation of each other, these are images that will run in isolation but can interact with each other. The Docker Compose files are very easy to write. They're all written with a scripting language called YAML, and YAML is an XML-based language. It actually stands for yet another markup language, but it's an XML-based language and it's very easy to use. The great thing about learning YAML is that a lot of open source tools in the DevOps environment use YAML as the scripting language. And then finally, in Docker Compose, as a user, you can actually go in and trigger all your services within the containers to start with a single command. As you can imagine, this dramatically reduces the amount of work that you as a developer have to do. So let's take an example of if you're running a container, one with a Nginx server and one with a Redis database. You can create a YAML Docker Compose file that actually has the instructions on the containers needed to build out both environments. And then you can run each of those environments separately, but have them connected as a single service. So the benefits of Docker Compose is that you have a single host deployment environment. You can run this all on one piece of hardware. You can have a quick and easy configuration using YAML scripts. The productivity that you get as a developer significantly increases because you're not having to have time wasted trying to configure just traditional Docker containers by themselves. You now have a way of being able to interact with those containers. And then finally, security is at the center of all of these containers. So each of those containers are completely isolated from each other, and they are controlled with the same level of security that you'd have with a traditional Docker image. But there is a question here around Docker Compose. Isn't it similar in concept to Docker Swarm? Because at a high level, it kind of seems like both do the same thing. And the answer is, well, actually, no, they're different. There are similarities, but there are also differences. And particularly for a developer, these differences will really start coming out in scale as you start working on your solutions. So let's look at Docker Compose. So Docker Compose will allow you to create multiple containers on a single host. And that's the important part, having a single host, which is maybe your development PC. With Docker Swarm, it also allows you to create multiple containers. However, you have to manage those multiple containers on multiple hosts, which makes a lot of sense if you're running an operations environment, but not so much if you're doing a development environment. And Docker Compose is scripted with YAML, which is very easy for you to be able to control your scripts. Docker Swarm doesn't have a scripting technology like YAML, so it's a little bit harder to work with. So what we have here is just some basic commands that allow you to get up and started working with Docker Compose. In our next demo, we're actually going to take you through how to use all of those commands. So we're going to go ahead and do a demo on how to use Docker Compose. The first thing you want to do is check that you have Docker installed. So what we're going to do is we're going to open up the command window and we're going to type in Docker. You'll be able to see now that we have Docker installed. If you don't have Docker installed, go ahead and install Docker. You can go to Google search to install Docker and they'll give you the instructions for that. We also have videos that we've already done. If once you have Docker installed, then you want to do a Google search on Docker Compose or go to the docker.com website and select for the Compose section and look for the install Docker Compose instructions. So we already have another tab which has the instructions already installed. You'll see on the left hand side there are a number of Docker tools. You want to expand the Docker Compose section, select install Compose, and then on the right hand side you'll have different install options for Mac, Windows and Linux. If you're installing on those platforms, make sure you're copying the correct command lines. There's a couple of command lines you want to copy. Copy the first one over and we paste that in. And it's going to go ahead and download all of the files for Compose. It takes a while, but we have to get another file. So while it's downloading, we'll go get the other command line. Just go back and grab it real quick. It was a little fast there, but we'll copy that over. There was a second command instruction and post that command. Yep, there's the command right there. And that will apply the appropriate binary. And once you've done that, you can actually go ahead and validate that you have the correct version of Docker Compose installed. And for that, you want to write the command docker-compose space -- version. And that will then give you a version build. Once you know that you have a version build, that means that you have everything installed correctly on your machine. So you can see here that we have a version number, which means we have everything installed. You might see a different version number depending on how old the video is when you're watching it, but we're using very content at the moment. And just go ahead and clear the screen. And now what we're going to do is create a folder where we're actually going to install the YAML file that will have the instructions for our Docker Compose environment. So we're moving the cursor to the desktop, and on the desktop we're going to create a new folder and using the mkdir command, and we'll call this one Docker Compose F for file. And then we'll move the cursor into that new folder by using cd command. And now we are in the folder called Docker Compose F. And you can go look at your desktop and you'll see it's there. And now you want to select #touch docker-compose.yml, and that will actually create the new YAML file for you. And you can use the ls list command, ls docker-compose.yaml, and that'll allow you actually now to step in and edit that file. So let's go ahead and hit return, and that'll allow us to go in and edit the file. So now I'm in the editor and I'm going to write some instructions. So I'm going to put a couple of mistakes in these instructions so we can see how Docker Compose catches those mistakes. But most of this is going to be fairly correct, so you can just type this out. So we're going to start with services : then we'll do web : and then we'll create image : and we'll do Nginx, and then we'll do a database : and we'll call the image Redis. And so what you can see, because we have two reference images, we're actually calling two different images, two different containers that will be created by Docker Hub. So what we're going to do is where we can actually show you how that's pulling in. You can go to Docker Hub and you can actually see the references to the images that we've just created. So go to Docker Hub, which is hub.docker.com, and you'll see that Nginx, Redis, those are the default names for the images. So you could do other images like HTTP for Apache web server if you wanted to. There are a lot of images in Docker Hub, so certainly have a lot of fun building tools from that environment. So we're going to save those files in the Docker image, and we're just going to do :WQ to exit this screen. Save the text. Let's go and run our YAML file, and you'll see the two different error messages that will come up. So we're going to do cat docker-compose.yml, and here we have a display of the text that we just wrote. And now let's go check the validity of the file that we just created. So we'll do docker-compose config, and we should get an error message. And there we are, error message. And the reason why we have an error message is because the spacing is not correct in the YAML file itself. So let's go to the actual YAML file that we created. Let's go through, and we're going to use just the file finder, and you'll actually open up the YAML file in your text editor, your favorite text editor. And here we have the code that created it. And let's use the correct spacing so that everything is spaced out appropriately in the image. And so this is the spacing that you'd expect to see, a line between surfaces and the first image, and the first image is a tab in, and then it references what the image is. And let's go ahead and clear the screen, and we'll see whether or not we've got that all correct. Let's clear the screen, and we're going to check that everything is running correctly. And we're still getting an error message, and the reason why we're getting another error is that there's still a config error in the actual YAML file. So one of the things you have to do when you're creating a YAML file for Docker Compose is you actually have to have the appropriate version number in there. So what we have to do is we have to go and find which is the appropriate version. And there are three major versions, 1, 2, and 3, depending on the age of Docker that you have installed on your computer. So if you have the very latest version of Docker, 18 and newer, you would put 3.7 as the version number. And what we're going to do is we're going to just check on the version that we have installed. And so we'll just clear the screen, and then we'll just do Docker version. And what we have is our version of Docker is 17.12. Now this is the version of Docker, not Docker Compose. It's your main Docker environment. And so if we go back to our web browser, we'll actually see that version 17 should align with version number 3.5. Yep, there we are, version 3.5. So what we want to do is go back into our YAML file, and the very first line that we want to put in above the services is the version number. And that version number we're going to put in is 3.5. So we type in version, and we put colon, and then version number is in quotes, and you save that. And now what we can actually do is we can actually go ahead and use the single line instruction to run both of these two images that we've created, because everything is configured correctly. But with just one note, you'll see that the version number is actually at the bottom of the list, and that's just the way that Docker Compose works. It pulls out the services and the images that you'd create, and then puts the version number at the bottom of the list. So in the presentation, we talked about how you can use one line to trigger two or more images. And so to do that, we're going to do sudo docker-compose -d. And it's going to create the two environments. We have the web environment and the database environment. And let's use sudo docker ps to actually list out all the processes that are running right now. And there we are. We actually see all of the images that are running. We have the names, the commands, the images, and everything's up and running. And if we want to close both of those images, we can actually use a single line of command as well. And that command will be sudo docker-compose down. And that closes both of the images. And we can see that all the databases and the web services images have been closed, and sudo docker ps will actually list that there is nothing running. And that's how to use Docker Compose.
How to Dockerize an Angular application. My name is Miro Juuso, and in the next few minutes I'll be walking you through building a Docker image for an Angular application, and then running the image locally on your workstation. As Angular is a front-end framework, we'll be using a web server called Nginx to serve the application HTML files. After this session, you will understand three things. First, what is Docker and what is it used for? You will understand the basics of Docker and what problem Docker fixes. Next, you'll learn how to write a Docker file, which you can think of as the recipe Docker uses to build your image. In this session, we'll be using a multi-stage Docker file to build our application. Third, you will learn how to use an Nginx server to serve an Angular application inside a Docker container. To follow through the examples in this session, you should have an Angular application ready and the latest version of Docker installed on your workstation. You can install Docker by following instructions on docker.com. First, let's look at what Docker is. Docker is the most popular containerization technology, and it has quickly become the de facto standard when talking about containers. Containerizing an application means packaging it and all its dependencies into a single, easily transportable and isolated container. This container will run in exactly the same fashion regardless of the computer it is run on. By providing this layer of consistency, Docker fixes the traditional "but it works on my machine" problem. Instead of distributing just our application, we're distributing a full runtime environment along with our application. While not exactly correct, it might help you to think of a Docker container as a lightweight virtual machine inside your computer. Your computer can run multiple Docker containers at the same time, stopping and starting them individually as required. A common problem in software delivery is dependency management. When one application is run on multiple development machines and multiple server environments, a small difference in the version of an external library can change the functionality of your application, making it behave differently on different environments. The beauty of Docker is that if you build your application into a container image and transfer the same container image to your colleague's computer, you can be sure that the application will function identically on both computers. This is because the container includes all dependencies for the application inside it. On the other hand, a Docker container should not have any dependencies to the host it's running on, apart from Docker itself. It's important for you to understand what images and containers are, and what's the difference between them. For the purposes of this session, you can think of a Docker image as something that holds a file system and some metadata in it. The metadata includes things like the name or tag of the image, and instructions for Docker like what command to run by default when the image is started. While the official Docker documentation is a bit vague about the meaning of names and tags, you should learn the basics of it. Every Docker image has at least one tag, and in fact, the same Docker image can have multiple tags pointing to it. Every image tag has a name part and a version part, separated by a colon. For example, the Nginx image has multiple tags representing different versions and different flavors of the image. There's a special version tag called latest, which points to the latest version of the image. All Docker commands default to using the latest version tag if no other version tag is explicitly defined. When you build an image on your local machine, or for example a build server, you can upload the image into a Docker registry. When you configure other machines to use the same Docker registry, you can download the same image to as many other machines as you like. There is an official Docker registry called the Docker Hub, and the model is the same as, for example, GitHub. You can store public images free of charge under your account, but you will need to pay to host private images. Having your images public is great for hosting open source projects, but for any commercial proprietary applications, you will most likely want to opt for hosting the images privately. If you don't want to use a third-party service, you can always run your own Docker registry. My advice is that unless you're planning on hosting a very large number of images, it's absolutely worth the cost to spend a few dollars per month on a hosted Docker registry, such as Docker Hub. Once your application ecosystem starts to build around Docker, the registry becomes a critical piece of infrastructure, and keeping it up and running can prove to be a substantial piece of work. When you build or download a Docker image to a computer and run it, it becomes a running container. If you don't tell Docker otherwise, Docker will run a pre-specified command inside the container. As far as this command is concerned, it is running inside a Linux server, and it has access to other commands and resources that are available inside the same container. You can think of a container as a sandbox, where processes running inside the container do not have access to the host system or other containers unless you explicitly specify otherwise. Note that the complete container runs around a single process created by the initial command used to start the container. If this process terminates for any reason, the container will stop. An example for our container would be the Nginx server process. When you start the container, the Nginx server process starts in it, and when the Nginx server process dies or is killed, the container will stop as well. It is possible to run multiple processes inside a single container by, for example, using an init system to spawn the processes you need, but for the purposes of this session, we'll use the concept of just a single process per container. The basic workflow with Docker is as follows. First, you will build a Docker image either on your workstation or on a continuous integration server. Second, you will push this Docker image into a Docker registry to make it available for other computers. Third, you will most likely want to run the image on a server that is accessible via the internet, so clients can access whatever server software is running inside your container. Most often this is an HTTP server, and in this session we'll be using the Nginx HTTP server. In software delivery environments that embrace continuous delivery, this workflow is often part of a fully automated pipeline. A pipeline like this can trigger from committing a piece of code into a version control system and thus automatically deploy a new version of your application into a testing or even production environment whenever you change your application code. As we discussed earlier, a container is isolated from the machine it's running on, as well as any other containers running on the same machine, unless you explicitly define connections between them. This is out of the scope of this session, but I recommend you spend some time after the session to learn about Docker networking and links between containers. In this session, we'll be running a single container that can connect to the internet through the host machine and expose a single TCP port for the Nginx server process. Building Docker images is done with Docker files. You can think of a Docker file as a text file containing a recipe to tell Docker how to build an image. The basic function of a Docker file is to be a list of instructions that incrementally manipulate an existing Docker image. The word existing here is important. While you can theoretically build a Docker image from scratch, in most use cases you will actually be using another Docker image as the base for your new image. Many frameworks and open source projects publish their own Docker images, which can be used by developers to build images on top of. In this session, we'll be using a new Docker feature called multi-stage builds. This feature is available from Docker version 17.05 forward, and it allows you to use one base image for building our application and another base image for serving it. This works brilliantly for our use case. While Angular is often used as part of the full mean stack, in this session we're only concentrating on Angular. I'm assuming you know Angular and how the Angular command line interface works, and that you have a package.json in your application directory. If you're not quite there yet, check out the excellent Getting Started guide on the Angular website. Please note that the functionality of Angular varies wildly between major versions. However, the fundamental idea behind containerizing an Angular application is the same. Our Docker file is going to have two stages. First, we'll need to build our Angular application using the ng build command. This will output the packaged application in the dist directory under our application root. In the second stage, we will place the files from the dist directory into a directory that's served by a web server, and finally run the web server itself. This is where the multi-stage build feature comes in handy. As you remember, a Docker container only has the software available which we've explicitly added into it. This means that for the ng build command to work, we need to have the Angular command line interface installed inside our Docker container. This is something we wouldn't want on our final Docker image because it's just extra weight. And on the other hand, we wouldn't want the web server inside the image we're building our application in. Because the Angular CLI is distributed as a node package, we can use the official node Docker image as the base of our first builder stage. Because Angular is a front-end framework, it doesn't come with a server-side component, other than the test server shipped with the Angular CLI. Unfortunately, this test server isn't fit to be run on production, so we'll want to use something else to serve the Angular HTML files. In this example, we will use a robust web server called Nginx to serve the Angular application. Please note you could just as well be using a server application like Apache or IIIT instead. I'm not going to be diving into the specifics of configuring Nginx. Nginx does come with good documentation, but more importantly, it also comes with an official Docker image. We can use the official Nginx Docker image as the base for our Angular application image. The good thing is that this makes our Docker file very short and simple. Let's have a look. This is the Docker file, and it's divided into two stages. The way the multi-stage build works in Docker is that we're actually creating multiple Docker images with a single Docker file, but we're only keeping the last image we've defined. This allows us to build the application first and then copy the resulting build artifacts into the next Docker image. The idea behind this is that our final Docker image won't have all the build time dependencies in it, which makes the resulting image nice and small. In the first stage, we'll use the from directive to instruct Docker that we want to use the Node 8 image as our base image. We're also using the asBuilder keyword, so we'll be able to reference this stage in our second stage later. The next directive is the copy directive. This command is for copying files and directories from our local machine to the Docker image. We're giving this directive two arguments: the location of our application code directory and the target path within the Docker container. In this example, our application code sits in test app, and we want to place it in the directory test app inside the container. The next directive is workdir. This tells Docker that all following commands should be run within the specified directory, which in this example is the application directory within the container. The next directives are the run directives. As you might guess, these directives instruct Docker to run commands inside the container. First, we're running npm install to install all node packages defined in the package.json file of our application. Then we're running ngbuild to package our Angular application in the dist directory. Now we'll get to the second stage, which is copying the contents of the dist directory into a directory that's served by default by Nginx. We're using the from directive again. This tells Docker to start building another image. We're defining the from image to be an image called Nginx, which is the official Nginx Docker image. This image is pre-configured to run the Nginx server and serve HTML files that are stored in a predefined directory. Next, we'll use the copy directive, but this time with the from argument. This tells Docker to not look for the source path in our workstation, but instead the previous stage in this Docker file. Essentially, We're copying the contents of the dist directory in the previous Docker image into a directory called user share nginx html inside our new image. The nginx Docker image will then serve the contents of this directory. Finally, we're using a directive called expose to tell Docker that the port 80 has a server running in this image. The port 80 is the default HTTP port, as you might know. Note that the expose directive alone isn't enough to actually expose the port when the image is run. You can merely consider this as a documentation feature, and will still need to explicitly map port 80 from the container into a port on the host machine. This enables you to connect to the mapped port on the host machine, which will then forward the connection into the container. To follow this session for your Angular application, create a file with these contents and place it in the parent directory of your application code. Remember to customize the paths in the file accordingly. Make sure the name of the file is Dockerfile written as one word with a capital D. Now that you've learned what a Dockerfile is and what one looks like for an Angular application, let's learn how to use it to containerize an example Angular application. For this, we'll be using the Docker command line interface. After you've installed Docker on your workstation, you can use the Docker command line interface to build and run images. To find the command line shell on a Mac, click on the Spotlight search icon on the top right corner of your screen and write Terminal followed by Enter. While the Docker command line provides many features, in this session we'll concentrate on two, the Docker build and the Docker run commands. First, let's navigate to the directory with our Docker file. The command we'll be using is docker build. We'll be giving the command the -t argument, which defines the tag for the image that will be built. For this, we'll be using the tag test app. The second argument for the docker build command is the build context. This is where Docker expects to find the Docker file. We'll use a single dot to denote the current directory and press Enter to start building. You can see Docker runs through every directive in the Docker file as a step, outputting the directive and the output of running it. Finally, you'll see that Docker has successfully built the image and tagged it as test app latest. As you might remember from before, since we didn't define the version tag, the tag latest is used automatically. Great work! Now, let's run the image we just built. For this, we'll be using the docker run command. We'll be giving the docker run command a few arguments. First, -i and -t to denote that we want to run the image in an interactive terminal, that is, running the container attached to our current terminal session so we can see the output and interact with the process. We'll also be using the -p argument to map the port 8080 on our workstation to port 80 inside the container. As you remember, the Nginx server is listening on port 80. With this mapping, anyone connecting to port 8080 on our workstation will get forwarded to port 80 inside the container. Finally, the last argument is the tag of the image we want to run. We're using test app latest. Now that the container is running, let's use our web browser to navigate to port 8080 on our local machine. And we can see our Angular application being served. Well done! You can see that Nginx by default outputs all the requests in the standard output of the container. After you've finished testing, press Ctrl+C in your terminal to terminate the Nginx process and thus kill the container you were running. And that's how you Dockerize an Angular application.
In this session, you will have a good understanding of what a virtual machine is and what a Docker is. Followed by that, we will have a major difference between Docker and the virtual machines. Also, we will discuss some of the key differences between Docker and virtual machines. And finally, a use case on what made BBC to use Docker. So the first one, what exactly is a virtual machine? It is an isolated computing environment that enables a person to use an operating system via a physical machine. Virtual machines provide the functionality of a physical computer. As you can see on my screen, there is a virtual machine, and this is how a typical virtual machine looks like. Now, let's look at what a Docker is. Docker is an operating system level virtualization software platform that enables software developers and IT administrators to create, deploy, and run applications in a Docker container with all their dependencies. And a Docker container is a lightweight software package that includes all the dependencies like frameworks, libraries, and many more, which are essentially required to execute an application. This is the architecture of Docker tool. Now, let's move on to our next main topic for the discussion, that is Docker versus virtual machine. When it comes to comparing the two, we could say the Docker containers have much more potential than virtual machines. As you can see on the left and right hand side, both the images look similar. Now, let's define the layers of virtual machine from the bottom up. Let's begin with the infrastructure. Infrastructure could be a computer system, a laptop, or a virtual private server, such as an Amazon EC2 instance, or Azure virtual machine, or GCP virtual machine instance. On the top of the infrastructure runs the operating system. An operating system is a software that manages hardware and software resources for the computer programs. On your laptop, this will be likely Windows, Mac OS, or Linux flavored operating systems such as Ubuntu. Next comes the hypervisor. A hypervisor is a firmware that builds and runs virtual machines. There are two types of hypervisors. Type 1 hypervisors are HyperKit for Mac OS, Hyper-V for Windows, and KVM for Linux operating systems. And Type 2 hypervisors are VirtualBox and VMware. Then we have the guest operating systems. Consider an example where you want to run two apps on your server in total isolation. This process would require two guest operating systems which will be controlled by a hypervisor. Virtual machines come with many dependencies, where each guest operating system will at least occupy 512 MB of your RAM. This is worse because each guest operating system needs its own CPU and memory resources. Eventually, this will be expensive. Then, on top of that, each guest operating system requires its own dependencies, such as binaries and libraries. Since every application has different dependencies, it requires its own set of libraries. Finally, it's the application. This layer consists of the source code for the application you have built. This was all about the virtual machine on a server. Here's what the same setup looks like when you're using Docker containers. Here, you'll notice that there are a lot fewer layers. Docker doesn't require a bunch of massive guest operating systems. Let me break it down from the bottom up again. Infrastructure and host operating systems are the same as we discussed for the virtual machine. Coming into the third layer, instead of a hypervisor, Docker uses Docker Engine. Docker Engine, or Docker, is a client-server application that builds and executes containers using Docker components. Next, we have our dependencies. Just like on the virtual machines, here dependencies are built into a template called Docker images. As you can see on the screen, each application is still isolated and occupies less space. Now, let's have a look at the significant differences between Docker and virtual machine. Let's start with the operating system first. Docker is a container-based model where containers are software packages used for executing an application on any operating system. On the other side, virtual machine is a container-based model. It utilizes user space along with the kernel space of the operating system. A kernel space is where the core of the operating system runs and provides its services to the user. A user cannot modify the space, and user space is the portion of the system memory in which the user's processes run. Docker containers share operating system kernels with other applications and result in a higher server efficiency. Hence, Docker provides the most substantial default isolation capabilities among the other configuration tools. On the other hand, virtual machines do not share the operating system. Also, it does not provide isolation in the host kernel. In Docker, multiple workloads can run on a single operating system. But in virtual machine, each workload needs a complete operating system or a hypervisor. The next significant difference between the two is the performance. In the case of Docker, they use the same operating system without any additional software like hypervisor. In case of virtual machines, performance issues are a major problem. It can be due to the several reasons like CPU constraints, memory allocation, network latency, and many more. Running multiple virtual machines lead to an unstable performance. Docker containers can start up quickly and result in less boot up time, whereas virtual machines do not start quickly and lead to a poor performance. Now, let's talk about the next difference, which is portability. With Docker containers, a developer can build an application and store it into a Docker image. Later, he or she can run it across any host environment. But when it comes to virtual machines, it has portability issues. Virtual machines do not have a central hub like Docker does, and it requires more memory space to store data. Docker containers are smaller than virtual machines, due to which the process of transferring files on the host file system is easier. On the other hand, dependency on the host operating system and hardware makes virtual machines less portable. While transferring files, virtual machines should have a copy of the operating system and its dependencies, due to which image size is increased and becomes a tedious process to share data. The boot up time between the both is very different. The application in Docker containers start without any delay since the operating system is already up and running. On the other hand, virtual machines take much longer time than it takes for a container to run applications. These containers were basically designed to save time in the deployment process of an application, whereas in virtual machines, to deploy a single application, virtual machine needs to start an entire operating system, which would result in a full boot process. So those were the major differences between Docker and a virtual machine. Now let's discuss the minor differences between them. Docker is not always in a running state. It stops when the stop command is executed, whereas the virtual machines are always running in the background, which will result in huge RAM consumption. Talking about snapshots. Docker has a lot of snapshots. A snapshot is an image that you can upload on a private repository to access it on another host. But virtual machines do not consist of any snapshots. In Docker, images can be version controlled just like Git. They have local registry called Docker Hub where users store and distribute container images. On the other hand, virtual machine does not have a central hub. They are not version controlled. Docker can run multiple containers on a system. Users can connect multiple containers using user-defined networks and shared volumes. Multiple containers can be accessed on the same machine and share the operating system kernel with other containers. Each container is isolated in user space. Also, Docker containers occupy less space than virtual machines and start instantly. Virtual machine can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Multiple containers can be started at a time on the Docker engine. The isolation environment allows a user to run and deploy several containers simultaneously on a given host. Virtual machines can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Now that I have told you the differences between Docker containers and virtual machines, let me show you a real-life case study of how PCC uses Docker. BCC News is a British news channel over 500 developers working across the globe. BCC News delivers broadcasts in almost 30 different languages and with over 80,000 daily news in English alone. The news channel ran more than 26,000 jobs with more than 10 continuous integrations with sequential scheduling. The company had issues with identifying a way to unify the coding process and monitor the continuous integration consistently. Also, the existing jobs took up to more time, that is, up to 60 minutes to schedule and perform its task. Docker allowed BCC News to eliminate job wait times and run jobs in parallel. It also gave the users the ability to work in a more flexible CI environment where entire code processes were unified and stored in a single place. However, Docker succeeded in spreading up the whole continuous integration process.
So we're going to go through a bunch of things today around Kubernetes. We're going to cover what Kubernetes is and why you should be using it, along with the features of Kubernetes. We're also going to take a little bit of a look at Kubernetes versus Docker Swarm, as the two technologies do tend to get referred to quite frequently. And then we're going to do a deep dive into the actual Kubernetes architecture itself and how Kubernetes runs and operates within your network. And then finally, we're going to look at some Kubernetes use cases of how you can actually apply best learnings that other companies have used with Kubernetes. We'll finish everything off with a demo where we actually step through and use some of the actual codes that you can actually use to run from your terminal window to actually activate Kubernetes itself. So with that said, let's jump in. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made an open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment, so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution, that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers, and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards, and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster, it's very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. And you really want to let Kubernetes do this, because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right-hand side, we have our nodes and the pods within our nodes, and within those pods are the containers. On the left-hand side, we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left-hand side, we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker/ slave architecture, and the slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you are probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's life cycle rather than to create the pods directly. We have a selector, which is an expression matched label label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filtered, organized, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, service is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password. And this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https. And this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency. And the way we do that is write the command sudo apt install docker.io. Got a typo, correct that quickly. And put in y, so for yes, and we continue. And that's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. And we're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl-s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc/apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db http apt-kubernetes.io/kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update. And it's going to run any updates from what we've created. And we want to check what's in the folder. And so we can do cat/etc/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install kubelet, kubec2, and kubeadm. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. All right, so we have installed kubelet, kubeadm, kubectl, and kubernetes CNI. And so we're going to go ahead and use sudo swap -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path that we have to type out, which is -f https raw githubs content.com corios flannel master documentation cube-flannel.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc/kubernetes/admin.conf, and then $home/.cube/config. And then the final one will be sudo chown $open paren id-u close paren $open paren id/-g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, I think I have a typo in my command here. Yep. Oh yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network. And so we're going to do that by writing the command sudo kubectl get pods -all -namespaces. And it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service, and we're going to do that with the command sudo kubectl run --image equals nginx. And we're going to put this into port 80, so it's going to be nginx-app --port equals 80 --environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app --port equals 80 --name equals nginx-http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. There we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful. So we're going to break out the presentation to the following areas. We're going to cover what Kubernetes is and why you want to be using it. We're going to introduce the actual architecture and provide an overview of how it contains the containers and the other components that you'd have within the architecture. We'll also compare Kubernetes with Docker Swarm, and one of the things that you hear with Kubernetes almost in the same breath is Docker. We have to be careful not to confuse Docker from a container point of view and Docker Swarm, which is a container management tool. And Kubernetes is also a container management tool. So we'll compare the two of those. And then we'll look at the hardware and software components, and then finally do a deep dive into the architecture of Kubernetes and provide a case study of where Kubernetes has been used successfully in the past. So let's jump into this. So what actually is Kubernetes? So Kubernetes is a tool that was designed to actually help manage and contain large groups of containers. It was developed originally by Google out of the Google Borg solution, and then open sourced by Google. The actual environment allows you to manage large groups of containers. So if you're a developer in DevOps and you're working with Docker, then you're used to the concept of a container. And you'll also know that containers and cloud technologies tend to be almost breathed in the same breath. So the work that you're doing with Kubernetes is to be able to manage large groups of containers inside of the cloud. The thing that's great about working with Kubernetes is that it is incredibly flexible and it allows you to have incredibly complex applications run efficiently. So let's step into why you'd want to use Kubernetes. So a couple of key points. Kubernetes itself is an open source solution originally developed by Google, but it is available on most cloud platforms today. So AWS, Google Cloud, Microsoft Azure, all of them support Kubernetes. And what you'll find is as you're setting up your infrastructure, particularly if you're using containers, you'll see that the support for Kubernetes is floated up very, very efficiently and effectively by all three vendors. It's extremely useful for being able to manage large modular environments, and that's really kind of the, I think one of the big benefits of Kubernetes is its modularity, is that it really breaks down containers into their smaller parts. And once you do that, it becomes much more efficient for you as an administrator to be able to manage that entire environment. The reproducibility of Kubernetes is extremely high. You can build out infrastructures very quickly and have them being able to manage and have containers coming on and off and killed and created to be able to help load balance your entire environment. And so again, we keep talking about containers, but that's really what Kubernetes is all about, is being able to manage your applications that are managed through containers and being able to do that in a virtualized infrastructure. And the thing that's also really good with Kubernetes is it's really easy to deploy solutions. You just have to use a simple curl call and you can actually push out your Kubernetes infrastructure. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. You have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes. And the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10, 15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm. And Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually, you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pod, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction and part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then will work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The schedule, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the container should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer, increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker, and we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose, and Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it. And you should be able to look and see whether or not you can add your own company to this list. Any more hesitation? Let's jump into some of the popular interview questions that you're going to get asked. We're going to break up the interview questions into three categories. It's going to be beginner, intermediate, and advanced. The beginner questions are really going to cover about 3/4 of the questions that we're going to ask here, and then the intermediate and advanced will finish out the final quarter. And the reason is that quite typically most interviews you'll be asked intermediate to beginner level questions, mainly beginner level questions, just so you can demonstrate your understanding of Kubernetes. And then there's always one advanced question that gets thrown out just to make sure that you really do know what you're talking about and you've done at least one or two Kubernetes environment setups to be able to validate your experience. So let's kind of jump into that first section, which is why is Kubernetes widely used? And your answer to this really comes into the fact that Kubernetes is widely used because of three distinct areas. One is that Kubernetes is an open source platform that is readily available for the management of containers and allows you to manage the deployment, scaling, and management of those containers. And so the first area is that it allows you for easy deployment of your containers, the ability to scale effectively within Kubernetes, not just vertically but horizontally for your containers. And then finally, the Kubernetes environment itself was really designed to make it easy to manage containers in small parts. Other key areas of why Kubernetes is popular is that Kubernetes is the single largest open source project out there. Since its launch in 2014, it's just grown in leaps and bounds. Around that project, there is just a huge community, both an online and physical community. There are just a large number of online groups that are supporting Kubernetes and allow you to get fast access to information. But in addition to that, there are also a lot of local meetup groups that cover specifically Kubernetes, whether as part of a DevOps group or as part of a dedicated Kubernetes group. The actual environment itself is a really robust way of being able to manage your containers. Containers are becoming the most popular way of being able to deploy cloud-based applications. Kubernetes is an effective and persistent storage environment. So Kubernetes is also able to effectively manage persistent storage, whether it's local storage as a SSD drive or a local hard drive, or whether it's cloud-based storage. And because of the way that Kubernetes is architecture, it's really designed for the cloud from the ground up. So it's a great way to get started in building out your cloud solutions. And then finally, the actual tools within Kubernetes are designed to help and manage the health and monitoring of the environment itself. So what is Google Container Engine. So the Google Container Engine is another open source solution, but it's designed for managing the Docker containers and clusters. And so Kubernetes is a container management solution, and Docker is the most popular container solution out there. And this is just a way of being able to bring the two effectively into each other, so that you can have Docker containers manage the application, and then Kubernetes manage the scale of your applications as they're vertically and horizontally scaled across your network. So what is the difference between Kubernetes and Docker? And this is important because Kubernetes and Docker are often dropped in the same sentence, and there's a lot of people that get confused between the two. So fundamentally, Kubernetes is about taking pods which contain containers which have applications in and deploying them at scale across a cloud network. Docker is the container solution itself. So the actual application itself is put into the Docker container. Because of this difference, Kubernetes is designed for auto-scaling, is highly available, whereas Docker simply isn't, because it doesn't have to worry about that within the container itself. The Kubernetes environment will check for liveness and readiness of the health of the entire infrastructure, whereas with Docker, it's just really going to check the services that are coming in and out of the actual application itself within the container. Kubernetes is complicated to set up. It really is just simply complicated to set up, and what you'll find is a lot of cloud services will actually do the setup for you, whereas Docker is very easy to set up. As you would expect with the tolerance ratio, there is high fault tolerance with Kubernetes, whereas with Docker is low fault tolerance. And again, this is fundamental in the two different types of strategy that Kubernetes and Docker have. They're both connected tightly with each other, but they both do different things. So what are the notable features of Kubernetes? One is the ability to do container balance. Kubernetes always knows where to place a container within its entire network, within the pods and with its infrastructure. The services are managed for security, network, and storage. It is self-monitoring, so it goes in and is able to check its own nodes for health and the containers within the nodes, so it makes sure that the applications are always running effectively. You can do the scaling effectively, both vertically and horizontally within Kubernetes. The solution is open source, so there's no actual fee for the actual Kubernetes service itself. And Kubernetes allows for storage orchestration. What does it mean by storage orchestration? Storage orchestration is that you're able to access and share either local storage, such as a hard drive or SSD drive, or a cloud-based drive. And my preference is always to go with cloud-based drive, because then you're really positioning your solution to be a true cloud-based application. So what are the main advantages of Kubernetes? Well, you get automatic rollback for changes that go wrong. You're able to automate a lot of the processes that would have been manual processes previously. You're able to scale the resources both vertically and horizontally easily and quickly. And then these three areas, the rollback, automating services, and being able to scale, indirectly allows you to save money by reducing the amount of time and people working on your operations environment. So let's break out the architecture of Kubernetes. So you're going to be asked to explain how is Kubernetes architecture structured. And there are three key areas. There's the application layer, there's the Kubernetes layer, and then there's the infrastructure layer. We're going to start off with the infrastructure layer. And so the infrastructure layer is our base layer, and this is where you make your clusters for your collections of storage and networking resources within Kubernetes. And this is where you would have, if your databases are your data stored locally on a hard drive or in the cloud, your core network and the VMs that you'd be building out your infrastructure on. These allow you to group many machines together into a single unit so that you're able to scale up and down very easily to meet customer demand. So let's talk about the middle layer, which is the Kubernetes layer now. So if we're looking at our architecture for our Kubernetes layer, it's really broken down for the core operating system, the Docker container environment, and the Kubernetes code itself. And this is where you're able to take machines and pull them together as a cluster so that they work within that Kubernetes system. You have a master controller within Kubernetes that actually then will go ahead and manage the scheduler, the control manager, the API server. And then you'll be able to cluster all of these Kubernetes together so that they're all working and processing as one single unit. And then finally, let's look at the application layer where you actually have your apps. And so the application layer, where you have your pool and your services, Kubernetes will use API to connect in and out of this layer. It's to run your applications within containers, and you use instructions that are written in YAML or JSON to actually set up those containers. And you actually have the environment running on a plan that examines these instructions, so it keeps the entire environment healthy. API ecosystem is used to interact with the cluster. You don't have to do that by yourself, so make sure that you're referencing that the APIs are secured and connecting in and out of the system. And so you have your schedule and control manager actually from the Kubernetes environment doing the hard work, and then the workers themselves execute the commands that are coming from Kubernetes. So you will be asked to kind of dig into some of the key areas, such as explaining the master node and listing its components. So the master node is comprised of 4 key components. There's the cluster store, the controller manager, the scheduler, and the API server. So 4 key components. Remember, 4 fingers, 4 components. And then you're going to be asked to maybe dig deeper into what is a cluster within Kubernetes. And so a cluster is really a combination of resources such as machines into a single node. And then those nodes are pulled together and work as a single cluster as a whole. Kubernetes will work with that whole cluster. And then once you're actually working with that whole cluster, if a node fails or needs to be removed, Kubernetes is able to do that quickly and effectively. So let's talk a little bit about what are the different types of controllers in Kubernetes. And there are 5 types of control manager. You have the node controller, the service account, the token controller, the endpoint controller, and the replication controller. And so the node controller controls and handles the node in the system. The service account enables access controls in the system. The token controller cleans up any tokens for non-existent service accounts. The endpoint controller joins services in pods to the endpoint objects. And the replication controller manages the pod lifecycle. So what is the role of the cloud controller manager within this environment? And so the role of the cloud control manager is really to help manage persistent storage. And so persistent storage is storage that's either local storage to the physical machine, such as an SSD or hard drive, or cloud-based storage. And this allows the storage to be shared across the entire network. What is the role of the Kube API server and the Kube scheduler? So the Kube API server is responsible for the establishment of communication between the Kubernetes nodes and the master components, and it does this through APIs. The APIs themselves are all commands that are REST-based commands, and it implements an interface, which means different tools and libraries can communicate effectively with each other. So what is the role of the Kube API server and the Kube scheduler? So the Kube scheduler actually does the distribution of work across the entire infrastructure. So the actual YAML scripts that you've written are executed appropriately at the right time. So you're going to be asked to explain persistent volumes in Kubernetes. So a persistent volume is just a place where you can store data. Again, this can be local data, as in a hard drive local to the physical machine, or it can be cloud-based data. So what is a kubelet and a kube proxy? So a kubelet is a service responsible for conveying information to and from the control plane itself. The process, the kube proxy itself is responsible for maintaining the work and the status within the node server. In addition, every node in the cluster runs a simple network proxy, and kube proxy routes requests to the correct container in that node. In addition, you'll have some basic and primitive load balancing and management of the node from the proxy itself. There's additional layers of management that get done outside of the proxy, but the proxy is also there to help do some localized load management. So what is kubectl? So kubectl is your command line or terminal window interface that allows you to execute commands, and later in this video we'll actually go through some of those commands. etcd is the store that configures the details and essential values, such as key value pairs, that are distributed across your entire network. It also manages the network rules and the post-forwarding of activity. So what are the disadvantages of Kubernetes? Well, the first is it's really hard to install and configure, and this is why Azure and many cloud services such as Google Cloud will actually do the installation and configuration of Kubernetes for you. It does take a long time to get up and running with Kubernetes, not so much for the actual software, but your own experience of being able to use Kubernetes. It is not simple to manage the service. You actually have to have a lot of experience, and this is why people get paid a lot for Kubernetes skills. It's a difficult environment to get up and running and be effective in that management. Again, Kubernetes is just not an easy platform to learn. It takes a lot of time and effort. And one of the disadvantages is that while Kubernetes itself is free because it is an open source project, getting the people who are skilled to using Kubernetes is expensive. All right, so those were kind of the introductory questions that you can expect to be asked in your interview. The next set of questions are really going to be on an intermediate and advanced level, and these are the questions that will be thrown out. You see these as being the trick questions, which are really there to test that you have the skill set to be able to implement and manage Kubernetes within a company. So what happens if a master node fails? What happens if a worker node fails? How would Kubernetes manage that? Well, Kubernetes is really designed for this kind of scenario. And so you can actually look at it, and the response would be is that the pod itself does not get affected. Kubernetes will actually respond and fix the failed node, whether it is needs to be repaired, whether it needs to be restarted, or needs to be replaced. So what is a service role in Kubernetes? So a service role is an abstraction for the pods. It provides a virtual IP address and allows clients to connect to containers running in the pods using that virtual IP address. And the command that you would use to get that, we would use some of these kubectl commands. It's quite a simple one. It's kubectl get services, and you get a full list then of all the services that are available. So how do I do a rollback in deployment? So there's a couple of ways you can do the rollback. The first is if you want to see the rollout history deployment, you would write kubectl rollout history deployment and then in square brackets deployment. If you want to just restore to the previous rollout, the command would be kubectl rollout undo deployment and then in square brackets deployment, and that would take you back to the previous deployment. So what is an ingress controller? So an ingress controller really is a pod that manages that inbound traffic, and a prominent feature of that traffic is that it is secured with an SSL termination. And so what we're going to do to now address some of the key ways in which you can provide API securities on Kubernetes, and we have 8 of those. The first 4 are implementing TLS for your security. The second would be API authentication. The third is to make the kubeless protection, the kubeless protected via authorization mode equals webhook command. The fourth is to monitor RBAC failures. The fifth is to remove those default service account permissions. 6 would be to filter egress to Cloud API metadata APIs. The 7th is to use pod security policy to restrict container policies and protect the node. And the 8th and final is to keep the kube at the latest version. All right, let's go into some of the more advanced commands. And so the advanced questions that you're going to get are all going to be commands that you're going to be asked to write. Now, my advice for you for these questions is to make sure that you have some of these basic commands memorized. They don't have to be perfect when you're in the interview environment, but it's good to be able to get up to a whiteboard and actually write out what these commands are, just so you can actually demonstrate that you know what the commands are. The interviewer isn't going to ask you questions on how would you apply Kubernetes to the company that you're being hired for, because you simply don't have that knowledge, but they do want to be able to see clearly that you understand the commands and terminal window instructions that will be able to demonstrate how you would actually go in and access some of that information. So one of the first questions you might be asked is, how do you package Kubernetes applications? And so you would use the package manager within Kubernetes to be able to manage and configure and deploy applications into your cluster. And so here we have the Helm command that you would use. So what are init containers? And an init container gets executed before any other containers can run on the pod. And so you want to be able to illustrate what the init instructions would look like. And here we have an example, and I would again use this example and maybe memorize it for when you have this question come up in your interview. So what is the difference between a config map and a secret? And these are more fundamental. So a config map just has the instructions that are clearly available in plain text on what the cube is supposed to do, whereas the secrets are actually encrypted, and these are like passwords and other sensitive data that you don't want to have easily available. These are encrypted information that have to be decrypted to access the content. So if a node is tainted, is there a way to schedule the pods to that node? And the answer is no, there isn't. And so what you have to do then is schedule the pod to be fixed, and so that schedule the pod to fix the tainted node to allow for tolerations to that. And we have here the example code that you would use to do that. So how do you deploy a feature with zero downtime in Kubernetes? Well, Kubernetes is designed to be able to roll out applications with zero downtime. And here we have 4 examples using the rolling update as a strategy for zero downtime deployments in Kubernetes. Again, memorize one of these so you can actually illustrate how you use rollout to be able to deploy a zero downtime solution. So how do you monitor a pod that is always running? And so to do that, you would use the liveness probe to check the health of the application within the pod and see whether or not there are any failures or whether or not the pod itself needs to be restarted. So how do you drain traffic from a pod during a maintenance? So again, this is a simple command for you to remember, but to be able to drain an application so that it's easy for you to be able to do maintenance on the application, you would use the kubectl drain and then in square brackets the node name, and that would then temporarily drain that particular pod so you can actually do maintenance on it. What you have to then, and this would probably give you bonus points if you're in an interview, is then reference the uncordon command so that you can uncordon the actual node itself so that the pod itself can come back up into live and work as a fully functioning solution. So to be able to tie services to a pod or to a set of pods is that you can apply labels to the actual pods themselves and then use the labels as selectors to be able to glue services to that pod. And again, we have here an example of how you'd actually do that. And again, this is one of those where you can probably won't be asked to write this out, but it'd be good to have this memorized. How do you get all pods on a node? And so the following command will actually go ahead and bring all the pods into a Kubernetes cluster. This is quite lengthy, and maybe you want to talk to how this would be done. But we have the instructions on how to do that right here. The important part is to make sure that you, when you're talking about the node name, that you reference to whoever you're interviewing what you would switch out to reference the actual nodes that you're trying to pull together into the Kubernetes cluster. So how do pods mount NFS volumes? And so in these examples here, we actually define the NFS server and then the pod and how you'd actually mount two together. Again, what you want to be able to do is illustrate why you would use YAML and how you'd actually then point to specific IP addresses within your Kubernetes environment, within either the production or test environments, to be able to illustrate how you would mount up those NFS volumes.
Before you start understanding any automation tool, it's good to look back into what manual testing is all about, what are its challenges, and how automation tool overcomes these challenges. Challenges are always overcome by inventing something new. So let's see how Selenium came into existence and how did it evolve to become one of the most popular web application automation tool. Selenium suite of tools. Selenium is not a single tool. It has multiple components. So we will look into each of them. And as you know, every automation tool has its own advantages and limitations. So we will be looking at what the advantages are and the limitations of Selenium and how do we work around those limitations. Alright, so let's get started. Manual testing. A definition, if you can say, a manual testing involves the physical execution of test cases against various applications. And to do what? To detect bugs and errors in your product. It is one of the primitive methods of testing a software. This was the only method which we knew of earlier. It is execution of test cases without using any automation tools. It does not require the knowledge of a testing tool, obviously, because everything is done manually. Also, you can practically test any application since you are doing a manual testing. So let's take an example. So say we have a use case. You are testing, say, a Facebook application. And in Facebook application, let's open the Facebook application and say create an account. This is your web page which is under test now. Now as a tester, what would you do? You would write multiple test cases to test each of the functionalities on this page. You will use multiple data sets to test each of these fields like the first name, the surname, mobile number, or the new password. And you will also test multiple links. What are the different links on this page? Like say forgotten account or create a new page. So these are the multiple links available on the web pages. Also, you look at each and every element of the web page, like your radio buttons, like your drop down list. Apart from this, you would do an accessibility testing. You would do a performance testing for this page, or say a response time after you say click on the login button. Literally, you can do any type of tests manually. Once you have these test cases ready, what do? You start executing these test cases one by one. You will find bugs, your developers are going to fix them, and you will need to rerun all these test cases one by one again until all the bugs are fixed and your application is ready to ship. Now, if one has to run test cases with hundreds of transactions or the data sets and repeat them, can you imagine the amount of effort required in that? Now that brings us to the first demerit of the manual testing. Manual testing is a very time consuming process and it is very boring. Also, it is very highly error prone. Why? Because it is done manually and human mistakes are bound to happen. Since it's a manual execution, testers' presence is required all the time. One needs to keep doing manual steps, step by step again all the time. He also has to create manual reports, group them, format them so that we get good looking reports. Also send these reports manually to all stakeholders. Then collection of logs from various machines where you have run your test, consolidating all of them, creating repositories and maintaining them. And again, since it's all is a manual process, there is a high chance of creating manual errors there. Scope of manual testing is limited. For example, let's say regression testing. Ideally, you would want to run all the test cases which you have written. But since it's a manual process, you would not have the luxury of time to execute all of them. And hence, you will pick and choose your test cases to execute. That way, you're limiting the scope of testing. Also, working with large amount of data manually is impractical, which could be the need of your application. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on application under test, and hence manually performing these kind of tests is not feasible. And to top it all up, say if you're working in an agile model where code is being churned out by developers, testers are building their test and they're executing them as and when the builds are available for testing. And this happens iteratively. And hence, you will need to run this test multiple times during your development cycle. And doing this manually definitely becomes very tedious and boring. And is this the effective way of doing it? Not at all. So what do? We automate it. So this tells us why we automate. 1, for faster execution. 2, to be less error prone. And 3, the main reason is to help frequent execution of our test. So there are many tools available in the market today for automation. One such tool is Selenium. Birth of Selenium. Much before Selenium, there were various tools in the market like say RFT and QTP, just to name a few popular ones. Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks and he was working on a web application which needed frequent testing. He realized the inefficiency in manually testing this web application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and he named it as JavaScript Test Runner. Later, he made this open source and this was renamed as the Selenium Core. And this is how Selenium came into existence. And since then, Selenium has become one of the most powerful tools for testing web applications. So how does Selenium help? So we saw all the demerits of manual testing. So we can say by automation of test cases, 1, Selenium helps in speedy execution of test cases. Since manual execution is avoided, the results are more accurate, no human errors. Since your test cases are automated, human resources required to execute automated test cases is far less than manual testing. Because of that, there is a lesser investment in human resources. It saves time, and time is money. It's cost effective as Selenium is an open source. It is available free of cost. Early time to market. Since you save effort and time on manual execution, your clients will be merrier as you would be able to ship your product pretty fast. Lastly, since your test cases are automated, you can rerun them any point of time and as many times as required. So if this tool offers so many benefits, we definitely want to know more detail about what Selenium is. Selenium enables us to test web applications on all kind of browsers like Internet Explorer, Chrome, Firefox, Safari, Edge, Opera, and even the headless browser. Selenium is an open source and it is platform independent. The biggest reason why people are preferring this tool is because it is free of cost. And the QTP and the RFT, which we talked about, are chargeable. Selenium is a set of tools and libraries to facilitate the automation of web application. As I said, it is not a single tool. It has multiple components, which we'll be seeing in detail in some time. And all these tools together help us test the web application. You can run Selenium scripts on any platform. It is platform independent. Why? Because it is primarily developed in JavaScript. It's very common for manual testers not to have in-depth programming knowledge. So Selenium has this record and replay back tool called the Selenium IDE, which can be used to create a set of actions as a script, and you can replay the script back. However, this is mainly used for demo purposes only, because Selenium is such a powerful tool that you should be able to take full advantage of all its features. Selenium provides support for different programming languages like Java, Python, C#, Ruby. So you can write your test scripts in any language you like. One need not know in-depth or advanced knowledge of these languages. Also, Selenium supports different operating systems. It has support for Windows, Macs, Linux, even Ubuntu as well. So you can run your Selenium test on any platform of your choice. And hence, Selenium is the most popular and widely used automation tools for automating your web applications. Selenium set of tools. So let's go a little more deeper into Selenium. As I said, Selenium is not a single tool. It is a suite of tools. So let's look at some of the major components or the tools in Selenium and what they have to offer. So Selenium has 4 major components. 1. Selenium IDE. It's the most simplest tool in the suite of Selenium. It is integrated development environment. Earlier, Selenium IDE was available only as a Firefox plugin, and it offered a simple record and playback functionality. It is a very simple to use tool, but it's mainly used for prototyping and not used for creating automation in the real-time projects because it has its own limitations like any other record and replay tool. Selenium RC. This is nothing but Selenium Remote Control. It is used to write web application tests in different programming language. What it does, it basically interacts with the browser with the help of something called as RC server. And how it interacts is it uses a simple HTTP post GET request for communication. This was also called as Selenium 1.0 version, but it got deprecated in Selenium 2.0 version and was completely removed in 3.0, and it was replaced by WebDriver. And we will see in detail as why this happened. Selenium WebDriver. This is the most important component in the Selenium suite. It is a programming interface to create and execute test cases. It is obviously the successor of the Selenium RC, which we talked about, because of certain drawbacks which RC had. So what WebDriver does is it interacts with the browsers directly, unlike RC, where the RC required a server to interact with the browser. And the last component is the Selenium Grid. So Selenium Grid is used to run multiple test scripts on multiple machines at the same time. So it helps you in achieving parallel execution. Since the Selenium WebDriver, you can only do sequential execution, Grid is what comes into picture where you can do your parallel execution. And why is parallel execution important? Because in real-time environment, you always have the need to run test cases in a distributed environment. And that is what Grid helps you to achieve. So all this together helps us to create robust web application test automation. And we will go in detail about each of these components. So before that, let's look at the history of Selenium version. So what did Selenium version comprised of? It had an IDE, RC, and Grid. And as I said earlier, there were some disadvantages of using RC. So RC was on its path of deprecation and WebDriver was taking its birth. So if you look at Selenium 2 version, it had an earlier version of WebDriver, and also the RC. So they coexisted. From 3.0 onwards, RC was completely removed and WebDriver took its place. There is also a 4.0 version around the corner, and it has more features and enhancements. Some of the features which are talked about are W3C WebDriver standardization, improved IDE, and improved grid. Now let's look at each of the components in the Selenium suite. Selenium IDE is the most simplest tool in the suite of Selenium. It is nothing but an integrated development environment for creating your automation scripts. It has a record and playback functionality and is a very simple and easy to use tool. It is available as a Firefox plugin and a Chrome extension. So you can use either of this browser to record your test scripts. It's a very simple user interface using which you can create your scripts that interact with your browser. The commands created in the scripts are called Selenese commands, and they can be exported to the supported programming language, and hence this code can be reused. However, this is mainly used for prototyping and not used for creating automation for your real-time projects. Why? Because of its own limitation, which any other record and replay tool has. So a bit history of Selenium IDE. So earlier, Selenium IDE was only a Firefox extension. So we saw that IDE was available since the Selenium version 1. Selenium IDE died with the Firefox version 55. That was, IDE was stopped supporting from 55 version onwards. And this was around 2017 timeframe. However, very recently, all new brand Selenium IDE has been launched by Apply Tools. And also they have made it a cross-browser. So you can install the extension on Chrome as well as an add-on on Firefox browser. So they completely revamped this IDE code and now they have made it available on the GitHub under the Apache 2.0 license. And for the demos today, we'll be looking at the new IDE. Now with this new IDE also comes a good amount of features. Reusability of test cases, better debugger, and most importantly, it supports parallel test case execution. So they have introduced a utility called Selenium Side Runner that allows you to run your test cases on any browser. So you can create your automation using IDE, say on Chrome or Firefox, but through command prompt, using your side runner, you can execute these test cases on any browser, thus by achieving your cross-browser testing. Control flow statement. So initially in the previous versions of IDE, there were control flow statements available. However, one had to install a plugin to use them. But now it is made available out of box. And what are these control flow statements? These are nothing but your if-else conditions, the while loops, the switch case, and so on. It also has an improved locator functionality. That means it provides a failover mechanism for locating elements on your web page. So let's look at how this IDE looks and how do we install it and start working on that. So for that, let me take you to my browser. So say, let's go to the Firefox browser. So on this browser, I already have the IDE installed. So when you already have an IDE installed, you will see an icon here which says Selenium IDE. And how do you install this? You simply need to go to your Firefox add-ons. Here, where it says find more extension, so just type in Selenium IDE and search for this extension. So in the search results, you see this Selenium IDE, just click on that. And now since I've already installed, here it says remove. Otherwise, for you, it is going to give you an add button here. Just click on the add button. It will install this extension. Once it is installed, you should be able to see this Selenium IDE icon here. Okay, so now let's go ahead and launch this IDE. So when I click on that, it is going to show me a welcome page where it's going to give me a few options. The first option is it says record a new test case in a new project. So straight away, if you choose this option, you can start recording a test case. In which case, it's going to just create a default project for you, which you can save it later. Then open an existing project. So you can open if you already have a saved project. Create a new project and close. So I already have an existing project with me for the demo purpose. So I'll go ahead and open that. So I'll say open existing project and I have created a simple script. What the script does is it logs me into the Facebook using a dummy username and password. That's all. It's a very simple script with few lines and this is what it's going to do. So what we will simply do is we'll just run the script and see how it works. For that, I'm just going to reduce the test execution speed so that you should be able to see every step of execution here. Alright, so what I'll do now here is I'll just adjust this window and I'll just simply say run current test. Alright, so I'll just get this side by side so that you should be able to see what exactly the script is doing. Okay, so now you're able to see both the windows. Okay, so now it's going to type in your user email here. There you go. And now it will enter the password and it has clicked on the login button. So it's going to take a while to say login. And since these are the dummy IDs, you are not able to log in here and you're going to see this error window. Fine. That is what is the expected output here. Now on the ID, if you look here, after I execute the test case, every statement or every command which I have used here is color coded in green. So that means this particular step was executed successfully. And then here in the log window, it will give you a complete log of this test case, right from the first step till the end. And your end result is, it says FB login, which is my test case name, completed successfully. Let's look at few components of this ID. The first one is the menu bar. So let's go to our ID. Alright, so the menu bar is right here on the top. So here is your project name. So either you can add a new project here or rename your project. So since we already have this project, which is named as Facebook. And then on the right, you have options to create a new project, open an existing project, or save the current project. And then comes our toolbar. So using the options in this toolbar, you can control the execution of your test cases. So first one here is the recording button. So this is what you use when you start recording your script. And then on the left, you have two options here to run your test cases. The first one is run all tests. So in case you have multiple test cases written here, you can execute them one by one sequentially by using this run all test. Else what you can do is, if you just want to run your current test, this is what you would use. Then IDE has this debugger option which you can use to do a step execution. So say for example, now whenever I run the scripts, it's going to execute each and every command here sequentially. So instead, if I just select the first command and say do step execution, alright, so what it does is, the moment it finishes the first command, which is opening of Facebook, right, I think which is already done here, yeah, alright, so once this is done, it is going to wait immediately on the second command and it says pause debugger. So from here, you can do whatever you would like to do. In case you want to change the command here, you can do that. You can pause your execution, you can resume your execution here, right? You can even completely stop your test execution, or you can just select this to run the rest of the test case. So if we say run the test case, what it is going to do is it's just going to simply go ahead and complete the test case. Now, there is another option here, which is, you see the timer there, which says test execution speed. So to execute your test cases in the speed you want. Say whenever you're developing an automation script, right, and say you want to give a demo. So you need to control the speed sometimes so that the viewer is able to exactly see all the steps which is being performed. And this gives you an option to control that complete execution, right? So do you see the grading here? So we have somewhere from fast to completely slow execution. So the previous demo which I showed was I controlled the speed and then I executed it so that we could see every command how it is being executed. Alright, so what's the next? This is called as an address bar. So whenever you enter an URL here, that is where you want to conduct your test. And another thing what it does is it keeps a history of all the URLs which you have used for running your test. Then here is where your script is recorded. So each and every instruction is displayed here in the order in which you have recorded the script. And then if you look here, you have something called as log and reference. So now log is an area where it records each and every step of your command as and when they get executed. Right? So if you see here, it says open https facebook.com and OK. So that means this command was executed successfully. And after the complete test case is done, it gives you whether the test case passed or failed. So in case there is a failure, you will immediately see this test case is failed in red color. Also, there is something called as reference here. For example, say if I click on any of this command, the reference tab, what it is going to show me is details of this command which I have used in the script. It gives you the details of the command as well as what the arguments have been used, or how is that you need to be using this particular command. Okay, so now what we'll do is let's go ahead and write a simple script using this IDE. So with this, you'll get an idea as how do we actually record scripts in IDE. So for that, I have a use case here, a very simple use case. So what we will do is we will open amazon.in, then we'll simply search for say product iPhone. And once we get that search page where all your iPhones are displayed, we will just do an assert on the title of the page. Simple. Alright, so let's do that. So first thing what I need is an URL. Okay, so first let me go to my Firefox browser here and say amazon.in. So why I'm doing this? Just to simply get the right URL, absolute URL path here. and so that I don't make any mistakes while typing in the URL. Okay, so I got this. So let me close all these windows. I don't need any of this. Let's minimize this. All right, so here what I'll do, in the tests tab, I'll say add a new test and name this test as Amazon search. Done. I'll say add. Now I'll enter this URL which I just copied it from my browser. Okay, and then I'll just say start recording. So what it did was, since I've entered the URL in this address box, it just opened the amazon.in URL. Now let's do our test case. So in my test case, what I said was I want to search for iPhone. Once I have this, I'm just going to click on my search button. So now this gives me a list of all iPhones. And then I said I want to add an assertion on the title of this page. So for me to do that, what ID gives me an option is I have to just right click anywhere on this page and you'll see the Selenium ID options here. So in this, I will select assert title and then I will close this browser. So that kind of completes my test case. So now take a look at all the steps which is created for me. So it says open slash because I've already provided the URL here. So either you can replace it with your regular URL or you can just leave it as it is. So what I will do, since this is going to be a proper script and I might be using this to run it from my command prompt also. So I'll just replace this target with the actual URL. And then what it is doing, it is setting a window size. Then there are whatever I did on that particular URL on that website, it has recorded all the steps for me. So this is where it says type into this particular text box, which is my search box. And what did it type? iPhone. This was the value which I entered. Now there was one more feature which I told you in this new ID, which I said it has a failover mechanism for your locating techniques. Now that is what this is. Now if you look here, this ID is equal to tab search text box. This is nothing but that search box where we entered the text iPhone. And it has certain identification through which this IDE identifies that web element. And that has multiple options to select that particular search box. So right now what it has used is ID is equal to tab search box. However, if you know the different locating techniques, you will be able to see here that it has other techniques also which it has identified, like the name and the CSS and the XPath. So how does this help in failover is, say tomorrow if amazon.in website changes the ID of this element, right? You are not going to come and rewrite the scripts again. Instead, by using the same script, what it will do is, if this particular ID fails, if it is unable to find the element using the first locator, which is the ID, it simply moves to the next available ones and it tries to search for that element until one of these becomes true. That is what was the failure mechanism which has got added now. It's a very brilliant feature because most of our test cases break because of element location techniques. Well, let's come back to this. So then we added an assert title, right? So what is assert title here? It simply captures the title of that particular page and it checks. This is all. A very simple test case. So what we will do now is we will stop the recording and then I've also given a close browser. So right now what I will do is I'll just comment this out. Why? Because if I just run this test case, it's going to be very fast and you might not be able to catch the exact command execution what has happened. All right. So right now I'll just disable it, so that it will just do all these test cases and it just stays there without closing the browser. So now I'll just say run the current test case. So your Amazon in is launched. Okay, it is typed in the iPhone. It's also clicked on the search. So it is done. So now if you look here, since we are in the reference tab, it is not able to show. So let's go to the log. And now let's see the log. So it's going to be a running log. So if you notice here, the previous examples which we have run for Facebook is also in the same log. So we will have to see the log from running Amazon search because that's our test case. So if you see here, every command line, right, was executed successfully. Assert title was also done and your test case was executed successfully. So it passed. Now what we will do is on this assert title, I'll just modify this and let's say just add some text. I'll just add double S here. Now this, by intentionally, I'm going to fail this test case just to show you that whenever there is a test case failure, how does the IDE behaves and how do you get to know the failures. All right. So I'll just run the test case again. So before that, let's close the previous window. All right, done. And now here I'll also uncomment the close because anyway it's a failure which I'm going to see, which I should be able to see it in the logs. So I'll close the browser after the execution of test case. Okay, so let's simply go and run the test case. Okay, Amazon.in is launched. It should search for iPhone now. Yeah, there you go. All right. Now it should also close the browser. Yes, it has closed the browser and it has failed. Now see here. Now this is the line where our command failed. Why? Because the expected title was not there. And if you look in the logs, it says your assert title on Amazon.in failed. Actual result was something different and it did not match with what we had asked it for. So this is how simple it is to use your IDE to create your automation scripts. So we saw all the components of IDE. We saw the record button, then I showed you the toolbar, I showed you the editor box and also the test execution log. So now let's come to what are the limitations of this IDE. With IDE, you cannot export your scripts, your test scripts to WebDriver scripts. This support is not yet added, but it is in the works. Data-driven testing, like using your Excel files or reading data from the CSV files and passing it to the script, this capability is still not available. Also, you cannot connect to database for reading your test data or perform any kind of database testing. With Selenium WebDriver, yes, you can. Also, unlike Selenium WebDriver, you do not have a good reporting mechanism with the IDE, like say for example, TestNG or ReportNG. So that brings us to the next component of the suite, which is Selenium RC. Selenium Remote Control. So Selenium RC was developed by Paul Hammond. He refactored the code which was developed by Jason and was credited with Jason as a co-creator of Selenium. Selenium Server is written in Java. It is used to write web application tests in different programming languages, as it supports multiple programming languages like your Java, C#, Perl, Python and Ruby. It interacts with the browser with the help of an RC server. So this RC server uses a simple HTTP GET and POST request for communication. And as I said earlier also, Selenium RC was called as Selenium 1.0 version. But it got deprecated in Selenium 2.0 and was completely removed in 3.0 and it got replaced by what? WebDriver. And we'll see why this happened and what was that issue which we had with the RC server. So this is the architecture of Selenium Remote Control at a very high level. So when Jason Huggins introduced Selenium, you know the tool was called as JavaScript program. And then that was also called as a Selenium core. So every HTML has a JavaScript statements which are executed by web browser. And there is a JavaScript engine which helps in executing this command. Now this RC had one major issue. Now what was that issue? Say for example, you have a test script, say test.javascript here, which you are trying to access elements from anywhere from the google.com domain. So what used to happen is every element which is accessible are the elements which can belong only to google.com domain. Like say for example, mail, the search or the drive. So any elements from this can be accessible through your test scripts. However, nothing outside the domain of say google.com in this case was accessible. Say for example, if your test scripts wanted to access something from yahoo.com, this was not possible. And this is due to the security reasons, obviously. Now to overcome that, the testers, what they had to do was they had to install the Selenium core and the web server, which contained your web application which is under test on the same machine. And imagine if you have to do this for every machine which is under test. This is not going to be feasible or even effective all the time. And this issue is called as a same origin policy. Now what a same origin policy issue says is it prohibits a JavaScript from accessing elements or interacting with scripts from a domain different from where it is launched. And this is purely for the security measure. So if you have written a scripts which can access your google.com or anything related to google.com, these scripts cannot access any elements outside the domain. Like as we said in the example yahoo.com. This was the same origin policy. Now to overcome this, what this gentleman did was he created something called as Selenium Remote Control Server, to trick the browser in believing that your core, your Selenium core and your web application under test are from the same domain. And this is what was the Selenium Remote Control. So if you look at again a high level architecture or how did this actually work, first you write your test scripts, which is here, right, in any of the supported language like your PHP or your Java or Python. And before we start testing, we need to launch this RC server, which is a separate application. So this Selenium server is responsible for receiving the Selenese commands. And these Selenese commands are the ones which you have written in your script. It interprets them and reports the result back to your test. So all that is done through your RC server. the browser interaction which happens through RC server, right, from here to your browser. So this happens through a simple HTTP and post and get request, and that is how your RC server and your browser communicate. And how exactly this communication happens? This RC server, it acts like a proxy. So say your test scripts asks to launch a browser. So what happens is this commands goes to your server, and then your RC server launches the browser. It injects the JavaScript into the browser. Once this is done, all the subsequent calls from your test script, right, from your test scripts to your browser goes through your RC. And now upon receiving these instructions, your Selenium core executes these actual commands as JavaScript commands on the browser. And then the test results are displayed back from your browser to your RC to your test scripts. So the same cycle gets repeated, right, until the complete test case execution is over. So for every command what you write in your JavaScript here or your test script here goes through a complete cycle of going through the RC server to the browser, collecting the results again from the RC server back to your test scripts. So this cycle gets repeated for every command until your complete test execution is done. So RC had definitely a lot of shortcomings, and what are those? So RC server needs to be installed before running any test scripts, which we just saw. So that was an additional setup since it acts as a mediator between your commands, which is your Selenium commands, and your browser. The architecture of RC is complicated. Why? Because of its intermediate RC server, which is required to communicate with the browser. The execution of commands takes very long. It is slower. We know why, because every command in this takes a full trip from the test script to your RC server, to the core engine, to the browser, and then back to the same route, which makes your overall test execution very slow. Lastly, the APIs supported by RC are very redundant and confusing. So RC does have a good number of APIs. However, it is less object oriented. So they are redundant and confusing. Say for example, say if you want to write into a text box, how and when to use a type key command or just a type command is always confusing. Another example is some of the mouse commands, using a click or a mouse down. Both kind of, almost providing a similar functionality. So that is the kind of confusion which developers used to create. Hence, Selenium RC got deprecated and is no more available in latest Selenium versions. It is obsolete now. Now to overcome these shortfalls, WebDriver was introduced. So while RC was introduced in 2004, WebDriver was introduced by Simon Stewart in 2006. It's a cross-platform testing platform, so WebDriver can run on any platform, like say Linux, Windows, Mac, or even if you have a Ubuntu machine, you can run your Selenium scripts on this machine. It is a programming interface to run test cases. It is not an IDE. And how does this work actually? So test cases are created and executed using web elements or objects using the object locator and the WebDriver methods. So when I do a demo, you will understand what these WebDriver methods are and how do we locate the web elements on the web page. It does not require a core engine like RC. So it is pretty fast. Why? Because WebDriver interacts directly with the browser and it does not have that intermediate server like the RC had. So each browser, in this case, what happens is each browser has its own driver on which the application runs. And this driver is responsible to make the browser understand the commands which you will be passing from the script. Like say for example, click of a button or you want to enter some text. So through your script, you tell which browser you want to work with, say Chrome, and then the Chrome driver is responsible for interpreting your instructions and to execute it on the web application launched on the Chrome browser. So like RC, WebDriver also supports multiple programming languages in which you can write your test scripts. So another advantage of WebDriver is it supports various frameworks like TestNG, JUnit, NUnit, and ReportNG. So when we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. So let's look at the architecture of WebDriver at a high level. What is in WebDriver? So WebDriver consists of 4 major components. The first one is we have got client libraries, right? Or what we also call it as language bindings. So since Selenium supports multiple languages and you are free to use any of the supported languages to create your automation script, these libraries are made available on your Selenium website, which you need to download and then write your scripts accordingly. So let's go and see from where do we download this. So if I go to my browser, so seleniumhq.org, right? So if you're working with Selenium, this website is your Bible. So anything and everything you need to know about Selenium, right? You need to come here and use all the tabs here in this website. So right now what we are going to look at is what are those language bindings. So for that, I'll have to go to this download tab here, okay? And if you scroll down here, you will see something like Selenium client and WebDriver language bindings. And for each of the supported language of Selenium, you have a download link, right? So say for example, if you're working with Java here, what you need to do is you need to download your Java language binding. So let's go back to the presentation. So this is where your language bindings are available. Next, so Selenium provides lots of APIs for us to interact with the browser. And when we do the demo, I'll be showing you some of these APIs, right? And these are nothing but the REST APIs. And everything, whatever we do through the script happens through the REST calls. Then we have a JSON wire protocol. What is JSON? JavaScript Object Notation. It is nothing but a standard for exchanging data over the web. So for example, you want to say launch a web application through your script. So what Selenium does it creates a JSON payload and posts the request to the browser driver. That is here. And then we have this browser drivers themselves. And as I said, there is a specific driver for each browser. As you know, every tool has its own limitation. So does Selenium. So let's look at what these limitations are and if there are any workarounds for them. Cannot test mobile applications requires framework like APM. Selenium is for automating web application. It cannot handle mobile applications. Mobile applications are a little different and they need its own set of automation tool. However, what Selenium provides is a support for integrating this APM tool, which is nothing but a mobile application automation tool. And using APM and Selenium, you can still achieve mobile application automation. And when do you usually need this? When your application under test is also supported on mobile devices, you would want a mechanism to run the same test cases on web browser as well as your mobile browsers, right? So this is how you achieve it. The next limitation, so when we talked about the components of Selenium, I said that with WebDriver, we can achieve only sequential execution. However, in real-time scenario, we cannot just live with this. We need to have a mechanism to run our test cases parallelly on multiple machines as well as on multiple browsers. So though this is a limitation of WebDriver, but what Selenium offers is something called as grid, which helps us achieve this. And we will see in shortly what the Selenium grid is all about. Also, if you want to know more details as how do we work with the grid, how do you want to install that grid, so do check out our video on Simplilearn website on Selenium grid. Third limitation, so limited reporting capability. So Selenium WebDriver has a limited reporting capability. It can create basic reports, but what we definitely need is a more. So it does support some tools like say TestNG, ReportNG and even Extent reports, which you can integrate with Selenium and generate beautiful reports. Powerful, isn't it? Also, there are other challenges with Selenium, like Selenium is not very good with image testing, especially for the ones which are designed for web application automation. But then we have other tools which can be used along with Selenium like AutoIt and Securely. So if you look at all this, Selenium still provides a complete solution for your automation needs. And that's the beauty of Selenium, and that is why it makes the most popular tool of today for automation. Okay, let's do a quick comparison between the Selenium RC and the WebDriver. So RC has a very complex architecture. You know why? Because of the additional RC server. Whereas due to direct interaction with the browser, WebDriver architecture is pretty simple. Execution speed. It is slower in RC and much faster in WebDriver. Why? Because in WebDriver, we have eliminated that complete layer of Selenium server, right? That the RC server, and we established a direct communication with the browser through browser drivers. It requires an RC server to interact with the browsers. We just talked about it. And whereas WebDriver can directly interact with the browser. So RC, again, we talked about this as one of the limitations, that we have a lot of redundant APIs, which kept developers guessing as which API to use for what functionality. However, WebDriver offers pretty clean APIs to work with. RC did not offer any support for headless browser, whereas in WebDriver, you do have a support for using headless browsers. Let's see the WebDriver in action now. Now for the demo, we will use this particular use case, and what this use case says is navigate to the official Simplilearn website, then type the Selenium in search bar and click on it, and click on the Selenium 3.0 training. So we are basically searching for Selenium 3.0 training on the Simplilearn website. First, let's do the steps manually and then we will go ahead and write the automation script. So let's go to my browser. On my browser, what I'll do is let me first launch the Simplilearn website. Okay, and here what my use case step says is I need to search for Selenium and click on the search button. So once I do that, it is going to give me a complete list of all kind of Selenium trainings which is available with Simplilearn. And what I'm interested in is the Selenium 3.0 training here. Once I find this on the web page, I need to go and click on that. Alright. So this is all the steps which we are going to perform in this use case. Okay. Now so for writing the test cases, I'll be using an IDE which is Eclipse. I've already installed my Eclipse and also I have installed Selenium in this instance of my Eclipse. Alright, so if you can see the reference library folder here, you will see all the jars which are required for the Selenium to work. Next, another prereq which is required for Selenium, and that is your driver files. Now every browser which you want to work with has its own driver file to execute your Selenium scripts. And since for this demo I'll be working with the Firefox browser, I will need a driver file for Firefox. Now driver file for Firefox is the Gecko driver, which I have already downloaded and placed in my folder called drivers. Now where did I download this from? Let's go ahead and see that. So if I go back to my browser and if you go to your seleniumhq.website, you have to go to this download tab here. In the download tab, when you scroll down, you will see something like third-party drivers, bindings and plugins. In this, you will see the list of all the browsers which is supported by Selenium. And against each of this browser, you will find a link which has the driver files. Now, since we'll be using the Gecko driver, this is the link where you need to go to, and depending on which operating system which you're working on, you need to download that particular file. Now, since I'm working on Mac, this is the file which I'm using. If you're a Windows user, you need to download this zip file and unzip it. So once you unzip that, you would get a file called Gecko driver for your Firefox or a Chrome driver for your Chrome browser. And then what you do is you just create a directory called drivers under your project and just place the driver files here. So these are the two prereqs for your Selenium. One is importing your jar files like this and then having your drivers downloaded and keep them under a folder where you can reference to. Okay. So now we'll go ahead and create a class. I already have a package created in this project. So I'll use this project and create a new class. So I'll say create new Java class and let's call this as search training. I'll be using a public static void main and I'll click on finish. So let's remove this auto generated lines as we do not need them. Alright. Now the first statement which you need to write before even you start writing the rest of your code is what you need to do is you need to define or declare your driver variable using your class WebDriver. So what I would do is I'll say WebDriver driver. Done. Alright. Now you will see that this IDE is going to flash some errors for you. That means it is going to ask you to import certain libraries which is required by the WebDriver. So simply just go ahead and say import WebDriver from org.opensq.selenium. This is the package which we will need. Alright. So you have a driver created which is of the class WebDriver. And now after this I'm going to create three methods. Alright. So first method I will have for launching the Firefox browser. Okay. And then I will write a simple method for searching Selenium training and clicking on it. This is the actual use case what we'll be doing. And then third method I'm going to write is just to close the browser which I'm going to be opening, right? So these are the different methods which I'll be creating, and from the public static void main I will just call these methods one after the other. Okay, so let's go ahead and write the first method. Now my first method is launching the Firefox browser. So I'll say public void, since my return type is null or there is no return type for this, let's call it as launch browser. Okay, all right. Now in this, for launching any browser, I need to mention two steps. Now the first step is where I need to do a system.set property. Okay, let's do that first and then I'll explain what this does. I'll just say system.set property. So this accepts a key and a value pair. So what is my key here? My key here is webdriver.gecko.driver, and I need to provide a value. So value is nothing but the path to the Gecko driver. And we know that this Gecko driver, which I'm going to use here, is right here in the same project path under the drivers folder, correct? And that is what the path which I'm going to provide here. So here simply I need to say drivers/Gecko driver. It's Gecko. All right, done. And let me close this sentence. All right. Now, since I'm a Mac user, my Gecko driver installable is just the name Gecko driver. If you're a Windows user and if you're running your Selenium scripts on the Windows machine, you need to provide a complete path to this, including .exe, because driver executable on your machines is going to be gecko driver.exe. Alright, so just make sure that your path which you mentioned here in the system.set property is the correct path. Okay, then the next thing what we need to do is I need to just say driver is equal to new Firefox driver. Okay, so this command new Firefox driver creates an instance of the Firefox browser. Now this is also flagging me error. Why? Because again it's going to ask me to import the packages where the Firefox driver class is present. Okay, we did that. Now these two lines are responsible for launching the Firefox browser phone. So this is done. So what's my next step in the use case? Now I need to launch the website Simplilearn. So for that we have a command called driver.get. Driver.get, what it does is whatever URL you're going to give it here in this double quotes as an argument, it is going to launch that particular website. And for us, it's a Simplilearn website. So what I do as a best practice is instead of typing out the URL, I go to my browser, launch that URL which I want to test, and I simply copy it. Come back to your Eclipse and just simply paste it. So this ensures that I do not make any mistakes in the URL. Okay, so done. So our first method is ready where we are launching the browser, which is our Firefox browser, and then launching the Simplilearn website. Now, the next method. What is my next method? In my next method, I need to give the search string to search Selenium training on this particular website. Now, for that, we need to do few things. What are those few things? Let's go to the website again. All right, so let me relaunch this. Let's close this. Okay, let me remove all this and let's go to the home page first. Okay, this is my home page. So as you saw, when I did a manual testing of this, I entered the text here. So now since I have to write a script for this, first I need to identify what this element is. For that, what I'm going to do is I'm just going to say right click here and I'll say inspect element. Alright, now this element, let's see what attribute it has which I can use for finding this element. So I see that there is an ID present. So what I'm going to do is I'm just going to simply use this ID and then I'll just copy this ID from here. Go back to Eclipse. Let's write a method first. So I'll say public void, and what do we give the method name? Say search training or just search. All right. Now in this, I need to use a command called driver.findElement by ID is what I'm going to use as a locating technique. And in double quotes, the ID which I copied from the website is what I'm going to paste here. Okay. And then what am I going to do on this element is I need to send that text, the text which I'm going to search for, which is Selenium. So I'll just say send keys, and whatever text I want to send, I need to give it in double quotes. So for that, Selenium. So this is done. So now I've entered the text here, and after entering the text, I need to click on this button. So for that, I need to first know what that button is. So let's inspect that search button. Okay. Now, if you look at the search button, other than the tag, which is span and the class name, I do not have anything here. All right. So what I can do is I can either use the class name or I can write an XPath. Since this is a demo, which we have already used ID locating technique, I would go ahead and use the XPath here. So for me to construct an XPath, I will copy this class first. Okay. And then I already have a crow path installed on my Firefox. So I'll use the crow path and first test my XPath. So I'll just say /. Let's see what was that element. It has a span tag. Okay. So I'll have to use span and at class equal to, and I'll just copy the class name here. And let's see if it can identify that element. Yeah. So it is able to identify. So I'll just use this XPath in my code. So I'll go back to Eclipse and I'll say driver.findElement by .xpath. and the XPath which I just copied from CrowPath is what I'm going to paste here. And what is the action I need to do here? I need to say click. Done. So I have reached a stage where I've entered this Selenium, okay, and then I have clicked on the search button. Once I do this, I know that expected result is I should be able to find this particular link here, Selenium 3.0 training, okay, and I should be able to click on that. So for that, again, I need to inspect this. So let's inspect this Selenium 3.0. Alright, so now what are the elements this has? Now this particular element has attributes like it has a tag h2, then it has got some class name and some other attributes. So I would like to use a XPath here. Now this time, while using the XPath, I'm going to make use of a text functionality so that I can search for this particular text. So I'll simply copy this. I'll go to my CrowPath. The tag is h2. So I'll say simply h2. Okay. And here I'll say text equal to, and this is the text which I copied. I missed out that yes there. So I'm just going to add an S. Okay. So let's first test here whether it is able to identify that element. Yeah. So it is able to identify. So can you see a blue dotted line? It is able to show us which element it is identified. So I'll copy this XPath now and let's go to my IDE Eclipse. So now here what I need to do is I'll have to again simply say driver dot find element by dot XPath and paste the XPath which we just did, and then again I have to do a click operation. Done. Alright. So technically we have taken all the steps of the use case and we have written the commands for that. Alright. Now let's add an additional thing here. Say after coming to this page, after finding this, we want to say print the title of this page. Now what is the title of this page? If you just hover your mouse on this, it says online and classroom training for professional certification courses Simplilearn. So what I will do is after doing all these operations, I will just print out this page title on our console. So for that I have to just do this driver dot so let's do a sysout. So I'll say sysout system.out.println. Okay, and here I would say let's add a text here. The page title is, and then let's append it with driver dot get title. So this is the command which we'll be using to fetch the page title. Done. Now what is the last method I need to add? Just to close the browser. Alright, so let me add a method here. I'll say public void close browser, and it's a one single command which I need to call. I'll say driver dot quit. Okay, and then I need to call all these methods from my public static void main. So I'll let me use my class name, which is this. So I'm going to create an object obj is equal to new class name, and then using this object, first is I need to call the method launch browser, and then I'll call the method search, right, and then I'll call the method close browser. Done. So technically our script is ready with all the functionality which we wanted to cover from our use case. Now there are few other tweaks which I need to do this, and I'll tell you why I need to do this. Now for example, after we click here, right, after we click on the search, if you observed on your website, it took a little while before it listed out all the Selenium trainings for us. And usually when you're actually doing it, you wait for the Selenium 3.0 training to be available and then you click on that. Now same thing, you also need to tell your scripts to do that. You need to tell your scripts to wait for a while until you start seeing the Selenium 3.0 training or it appears on your web page. There are multiple ways to do that in your script, and it is a part of overall synchronization, what we call, where we use kind of implicit and explicit kind of ways. Now since this is a demo, for demo purpose, what I'm going to do is I'm going to use a command called thread.sleep, and I'm just going to give an explicit wait of say 3 seconds. So you can use this mainly for the demo purposes. You can use a thread.sleep command. Now this thread.sleep command needs us to handle some exceptions. So I'm just going to click on add throws declaration and say interrupted exception. Now same thing I'll have to do it in my main function also. Okay, so let's do that and complete it. Alright, so this is done. So by doing this, what am I doing? I'm ensuring that before I click on the Selenium 3.0 training, we are giving enough time for the script to wait until the web page shows this link to the Selenium 3.0 training. That's one thing I'm doing. Alright, and also now since you're going to be seeing this demo through the video recording, the script when it starts running, it is going to be very fast. So you might just miss out seeing how it does the send keys and how did it click on the search button. For us to enable us to see it properly, I'll just add some explicit weights here just for a demo purpose. So after entering the keys, right, so what I'll do is I'll just give a simple thread.sleep here. Okay, so probably a 3 seconds or a 2 seconds wait should be good enough. Okay, a 3 seconds wait should be good enough here, so that we should be able to see how exactly this works on your browser when we execute this. Okay, now our complete script is ready. So what I'll do is I'll just save the script and then we will simply run the script. So to run the script, I'll just say right click, run as Java application. Okay, it says asks me to select and save. I've saved the script now. So let's observe how it runs. Okay, the Simplilearn.com, the website is launched. So the Selenium text has been entered in the search box. It has clicked on the search. Okay, all right. So now it did everything whatever we wanted it to do. All right. So since we are closing the browser, you were unable to see whether the Selenium 3.training was selected or not. However, what I have given here is to fetch the title after all these operations were complete. And if you see here, the complete operations was done and we were able to see the page title here. Okay. So now what I'll do, since we are unable to see whether it clicked on the Selenium 3.0 training or not, I'll just comment out the close browser, the command. Okay. So we will not call the close browser so that the browser remains open and we get to see whether did it really find the training link or not. Okay. So let me close this window. We don't need this Firefox window. Close all tabs and then I'll just re-execute this script. So I'll say run as Java application. So save the file. Okay, Simplilearn.com is launched. So search text is entered. Now it's going to click on the search button. Yes. All right. So we've got the search results. It should click on Selenium 3.0 training and yes, it is successfully able to click on that. All right. So now it's not going to close the browser because we have commented on that line. However, it did print us the title here. All right. So this is a simple way of using the Selenium scripts. Selenium Grid. So Grid is used to run multiple test scripts on multiple machines at the same time. With WebDriver, you can only do sequential execution, but in real-time environment, you always have the need to run test cases in distributed environment. And that is where Selenium Grid comes into picture. So Grid was conceptualized and developed by Patrick. The main objective is to minimize test execution time. And how? By running your test parallelly. So design is in such a way that commands are distributed on multiple machines where you want to run test and all these are executed simultaneously. What do you achieve by this methodology? Of course, the parallel execution on different browsers and operating system. Grid is pretty flexible and can integrate with many tools. Like say you want a reporting tool integrated to pull all the reports from the multiple machines where you're running your test cases and you want to present that report in a good looking format. So you have an option to integrate such report. Okay, so how does this grid work? So grid has a hub and node concept which helps in achieving the parallel execution. Let's take an example. Say your application supports all browsers and most of the operating system. Like as in this picture, you could say one of them is a Windows machine, one of them is a Mac machine and another one is say a Linux machine. So your requirement is to run the test on all supported browsers and operating systems, like the one which is depicted in this picture. So what you have to do is, first thing is you configure a master machine or what you also call it as a hub by running something called a Selenium standalone server. And this standalone server can be downloaded from the Selenium HQ website. Using this server, you create a hub configuration, that is this node. And then you create nodes specific to your machine requirement. And how are these nodes created? You again use the same server, which is your standalone Selenium server, to create the node configuration. So I'll show you where the Selenium server can be downloaded. So if we go back to our Selenium HQ website, so you can see here right on the top, it says Selenium standalone server. And this is the latest version available. So you just need to download. Once you download this, keep a version of this one on your master machine, that is your hub, and this should also be present on your node machines. And there is a certain command which you can use to install this server as a node and as a master depending on your configuration. So once that is done, you have your master or the hub and the nodes created. Your master can control on which nodes you want to execute test. Now say if this is a Mac machine, this is a Windows machine, through your master or your hub, you control on which machine you want to execute what tests. Then also you could have a multiple combination of tests. Like say for example, smoke test to be run on all these nodes. That's the kind of configuration you can create. Or a certain component test to be run on say only Windows 10 with an Edge browser. Or say regression test on Mac machine. So any such things, whatever configurations you have for your node, what happens is the hub picks the right node which conforms to your requirements or the configurations which you have set up, and then sends a command to the node to execute those test cases on the node. Everything is controlled through your master machine only here. What happens on the node? So once the node gets the command from the master, the node actually runs all the test cases which it intends to run on the specific browser which you have mentioned in your configuration file. So this is a very high level architecture and how a grid works. So if you want to know more details of how the grid works, you can refer to our video on Simplilearn. Alright, again, limitations. So what limitation does this grid have now? The first one, it has relatively poor scalability compared to many modern applications. It is pretty static. Each server is configured in advance with a subset of required browser instances available. So if you want to vary this, you will need to reconfigure. So any configuration tomorrow on any machines you want to change, it cannot be done automatically. You need to completely reconfigure that node and then add it back to the grid. Thirdly, although it is available to run on virtual servers, it is actually not designed as a cloud native application. And as a result of this, it isn't optimized to take advantage of things like say distributed storage or dynamic scaling or even automatic failover. So these are some of the limitations of the grid. Advantages of Selenium: speed and accuracy. Of course, since there is no manual execution, your test can run faster, and with grid, it helps in parallel execution, and you can run or execute large volumes of tests within a very short time frame. Let's take an example. Say just before the release of your product, say during the last lap of your testing, you find a bug, and of course it has to be fixed. So the developer fixes the bug and you want to run all the test cases pertaining to that area. Now can you imagine that if you have to do this testing manually, how long it's going to take? So by automation, you can achieve this in a very short duration of time, and it will also help you release your product in time with very minimal or absolutely no human errors. The second advantage, it's an open source, so it's available free of cost, so anyone can download it and start using it. It supports wide spectrum of programming languages we have been seeing throughout this presentation. It is not restricted to any particular programming language. So whatever language you are comfortable with, you have an option to use that and write your Selenium scripts. Selenium has support for almost all browsers and operating systems. We also talked about headless browser support. So this helps you create test cases once using any of the browser and run them across all browsers and all operating systems, thus saving you a lot of time from manual execution and helping in achieving a very broad test coverage. And we also saw that pretty easy to use tool, right? So you can check out all our videos and it's just a matter of time that you can master the skill of writing your automation scripts. Reusability. Of course, like any programming language, it provides you a mechanism to reuse your code and avoid redundancy. Well, again, let's see an overall what are the limitations of Selenium itself. Now, since Selenium is open source, that is one of the biggest advantage. Now, there is a little disadvantage which comes with that. And what is it? You do not have much technical support because it's an open source code. However, there are loads and loads of documentations and forums available which you can definitely refer to. And Selenium, as we said, it is only for automating web applications. It cannot handle the mobile applications or even the desktop application. However, it does provide support for integrating tools like APM for mobile testing. Selenium is not very good with image testing, especially designed for your web application tools. Again, we have tools like AutoIt and Securely which can be integrated with Selenium. Selenium WebDriver has limited reporting capability, but again, it does provide us support for integrating tools like TestNG, ReportNG, and ExtentReport. It does not have test management capabilities. It need not, right? Not one tool need not have each and everything what is required, but there is always a way to integrate it. So Selenium does provide a way to integrate any of the test management tools. Now, since Selenium supports multiple programming languages, the developer of test automation will require to have some basic knowledge of any of the programming language it supports to write effective automation scripts, right? So this you could look at it as an advantage or as a disadvantage. So overall, if you look at all this, right? Selenium still provides a complete solution for our automation need. And that is why we can still say that Selenium is one of the most popular tool used in the industry today for your web application automation. So this video consists of 3 parts, basically 3 different levels of set of questions. One is the beginner level, second is the intermediate level, and then the advanced level questions. And each level has a set of 10 most probable questions which you might be asked in the interview. So let's begin with the beginner level questions. Question 1. What are Selenium Suite components? So Selenium is a set of tools and libraries to facilitate automation on web applications. You already know this. It is not a single tool. So what are those components which are comprised in the Selenium? So Selenium comes with 4 major components. The first one is the IDE. IDE happens to be the most simplest tool in the whole suite of Selenium. It is nothing but an integrated development environment which has a record and playback functionality. This was earlier available as only Firefox plugin. However, you need to know that the new version of Selenium IDE is available as a Chrome extension as well as a Firefox plugin. So that means you can either use any of the browsers, that is Firefox or the Chrome, for recording your test scripts. Also, you should also know that the new IDE comes with many new features, and now this new IDE has become more powerful than what was available earlier. So some of these new features are like reusability of your test cases. It comes with a better debugger now, and most importantly, it supports parallel test execution. And how does it do that? It has a utility called Selenium Siderunner. That's about Selenium IDE. The next component is the Selenium Remote Control. So Selenium Remote Control, or popularly called as Selenium RC, is used to write web application tests in different programming languages. It supports multiple programming languages like Java, C#, Perl, Python, Ruby, and PHP. It is nothing but it's a server which interacts with your browser using a simple HTTP GET and POST request for communication. Selenium RC is also called as Selenium 1.0 version or Selenium Core. Third component, Selenium WebDriver. It is a programming interface to run your test cases. And WebDriver was introduced by Simon Stewart in 2006. And this was introduced to overcome some of the limitations of Selenium RC. So RC's architecture was very complex because it required an additional server in its setup. And why was that additional server? For communicating with the browser. And what WebDriver did was it removed this dependency completely. WebDriver interacts directly with the browser and also makes your test cases run much faster than your RC. The last component, the Selenium Grid, a very important tool. This is used to run multiple test scripts on multiple machines at the same time. Now with the Selenium WebDriver, you can only do sequential execution. But in real-time environment, you always have the need to run test cases in a distributed environment. So this grid allows parallel execution of tests on different browsers as well as different operating systems. So the design is in such a way that commands are distributed on multiple machines where you want to run the test, and they are executed simultaneously. This uses a simple hub and node concept where hub controls the all execution of your test cases on the nodes. And this is how we achieve parallel execution. And what is the major advantage of having this grid? It is to reduce your overall test execution time. Question 2. What are the limitations of Selenium? Now, like any other tool, Selenium also has certain limitations. So when you're answering this question, you will also be expected to talk about what is the workaround available for all these limitations. So let's look at them one by one. No reliable tech support. Of course, Selenium is an open source. So if you look at it, you do not have much technical support available. However, there are loads of documentation available. There are forums available which you can refer to. SeleniumHQ.org is the website, is your Bible if you're working with the Selenium. And then there are a lot of Selenium Google groups and the forums which are available for any kind of support. So Selenium has been there for quite some time. So it's one of the most mature tool available today. So even though we do not have a technical support available, there is enough documentation available on the internet. The second limitation, Selenium can test only web application. Selenium is an open source tool that is designed to automate web-based applications on different browsers. But it cannot handle Windows GUI or non-HTML pop-ups in the application. Now, what is the workaround available for that? Selenium provides a support for integrating other tools like AutoIt. So AutoIt is a tool for handling your Windows-based activity. Selenium also cannot automate mobile applications. But then what is available with that? It can integrate a tool called APM tool, which is a mobile automation tool. The third limitation, limited support for image testing. Selenium is a de facto tool for functional web application tests. So standard API allows interacting only with the browser, and it's hard to test the images based applications using Selenium. What is the other tool available? Seculi is a very good tool to use for image testing. And this again, you can integrate Seculi with Selenium. That's how you can achieve your image testing through Selenium, but using the Seculi tool. No built-in reporting facility. So Selenium does not have any reporting capability as such. Of course, it does provide a very limited reporting capability where some basic reports are created. But definitely when you are working in a framework, you need a better support for good reporting tools. So that way Selenium supports some of the tools like TestNG, ReportNG and Extend Reports, using which you can integrate these tools with Selenium and generate beautiful reports. Limited test management. Selenium does not provide any test tool integration with test management tools. May require knowledge of programming languages. So since Selenium supports multiple programming languages, the developer of the test automation will require to have some basic knowledge of any of the supported programming language. Why? One, in order to write your effective automation scripts. And of course, because Selenium tool, you want to use it at its full potential. Question 3. What are the testing types supported by Selenium? So Selenium supports regression testing and functional testing. These can be called as a very high level categories. So what is regression testing? Regression testing is a full or partial selection of already executed test cases which are re-executed to ensure your existing functionality does not break. So let's look at what are these attributes of regression testing and why we say that Selenium helps us in doing regression testing. So regression tests are run every time a new fix has been received or a new feature has been deployed. So that is called as retesting. You can always select a full suite or select a test to test a fix or a complete product. So your selection can be based on recently added features, a test area where most defects are there, or integration areas, or even end-to-end kind of tests. You can also prioritize your test cases based on critical functionalities and business impact of these test cases according to the priority set. So all this can be done using Selenium. Now, what is the second category of the testing which it supports? Functional testing. So functional testing includes what? Your smoke test, sanity test, say install test, database test. Basically any kind of functionality which you're going to test. And if you look at the kind of steps which are involved in that, it involves identification of your test inputs, expected outputs or the results, the test case logic itself and the assertions. So a typical flow will be you identify your test inputs first, then you derive your test outcomes or the expected outputs, you design and execute your test cases and then assert on the expected versus actual outcomes. Question 4. What are Selenium 2.0 and 3.0 versions? So Selenium was introduced by a gentleman called Jason Huggins way back in 2004 and that was Selenium version. Since then, this tool has gone through multiple changes to make it better and better. So if Selenium 2.0 version had a major change, it took a leap forward in terms of browser automation. The Selenium RC, the remote control, had a disadvantage of having the need of an additional server to talk to the web browsers. And because of this, the text execution was much slower and the architecture itself became very complex. So if you look at this Selenium 2, it had two components, a successor to RC and the RC itself, which is called as your core. So this successor was nothing but your WebDriver API. So WebDriver APIs made it easier to write your automation scripts for any browser by simply using a suitable driver for any browser which you want to run the tests on. Apart from these two components, the Selenium 2.0 version also had the IDE and the grid components. So in summary, if you look at it, Selenium 2.0 version has an IDE, it has Selenium RC which was on its way of deprecation, WebDriver API which was just introduced in there, a very earlier version of WebDriver API and the grid. So what did Selenium 3.0 consist? So Selenium 3.0 RC was completely eliminated now because in 2.0 it was already on its path of deprecation, and WebDriver replaced RC completely. So if you look at the components of 3.0, we have IDE, we have a WebDriver and Grid as the major components. So now with this introduction of WebDriver, a full-fledged WebDriver, Selenium became the most powerful tool for web application automation. Question 5, a very important question. What is same origin policy and how is it handled? Now, same origin policy is a security IT feature. So it is a very important concept in web application security model. And what is this? According to this policy, a web browser allows scripts from one web page to access the contents of another web page, provided both these pages are on the same origin. Now, what does origin mean? Origin is nothing but a combination of your URL schema, the host number, and the port number. It's basically your domain. Now, if such question is asked, how are you going to explain it? So let's say you have a JavaScript program which runs in a certain domain, say google.com. Okay, so this program can access all the programs which are from the same origin. Now origin here is what? Google.com. So for example, you can access other pages like your Google Drive, your Google email, or your Google Calendar. However, now if you use the same JavaScript, right? So if you use the same script from the google.com to access another page or an element in a different domain, say yahoo.com, then the security model of the web application itself prohibits you to do so. So what happens because of that is you are limited with access only to those elements and pages which are in the same domain. But now look at a case that you want to run your test on multiple servers and you might also want to access multiple domains. So due to the same origin policy, you will not be able to do so. And this became a major limitation with a very early Selenium tool. So how was this handled? So this got handled by Paul Hammond, who created the Selenium remote control. So he created a Selenium remote control server to trick the browser in believing that the Selenium core and the web application under test actually came from the same domain. And this is how the same origin policy was handled. And this Selenium RC, which is Selenium remote control, became the version 1 of Selenium. Question 6. What is Selenium and how is it classified? Selenium commands for Selenium IDE are often called as Selenium. They are a set of commands that run your test, and sequence of this command is called as a test script. Now these commands are categorized into 3 major categories. One is the action command. Now action commands are the commands that generally manipulate the state of your application. For example, they can do things like click on this link or select a particular option, open a URL, type certain text into an input box, click or double click on any web element, and so on. So these are called as action commands. The second set of commands is the accessors. Now accessors examine the state of the application and store the results in a variable. So it basically allows the user to store certain values to a user-defined variable. For example, if I want to store the page title of a web page, I can do that by defining a user-defined variable. And then these stored values can be later used to create your assertions or verifications in your test. Now, few examples of such commands are, you can just use a store, S-T-O-R-E, or a store text, store title, or a store value. So these are some of the accessor commands. The third category is the assertions. Assertions are like your accessors, but they verify the state of your application and conforms to what is expected. So basically it is a comparison of your actual versus expected results. There are 2 types of assertions available. One is the soft assertions and the hard assertions. An example of a soft assertion can be verify title, wherein you verify the title, check whether the expected and the actual outcomes are the same, and continue with your test case. Now, whereas an hard assertion is you do an assert title using the command assert title, and if at all the assertion fails, the test case stops from executing. Question 7. Mention the types of web locator. What is web locator? A locator is a command that tells the Selenium which UI element you want to operate on. Selenium uses locators to find and match the elements of your web page which it needs to interact with. And there are around 8 locating techniques in Selenium. The first one is by ID. Now this is the most common way of locating elements. Why? Since the IDs are supposed to be unique for each element. The IDs can also be dynamic in nature. So you can identify them by inspecting the attributes of the web element. So let's look at an example. So if we go to a Facebook, right? So if you go to the Facebook and say if I want to identify this element email. So if you look at this highlighted text here, it has a unique ID which is email. So if I'm going to operate on this particular element email, I can directly use the ID locating technique. Link text and the partial link text. So this type of locator applies only to the hyperlink text. So we access the link by using this locator which needs the hyperlink text to be provided. So for link text, you can give a complete text in the link text. Or let's look at an example of that. So if we go to say one of the e-commerce site, which is say amazon.in, and say you want to click on this today's deal link. So if you look here in amazon.in, there are a lot of hyperlinks available here. And if you have to take an example, say we want to click on the today's deal. Now, if you inspect this element, you will see that it has an anchor tag A. It has an associated href link here. And also it has a text which says today's deal, right? Which is what is displayed on your web page. Now similarly, there is also a link available here called customer service. So if you inspect that customer service, it also has something similar what the today's deal had. It has an anchor tab, it has an href link, and it has a long text which says customer service, which is what is displayed. Now if you have to use your web locator, which is a link text, you need to provide the complete text which is displayed on your web page. And there is another way of using the link text by saying partial link text, where you can just give a partial text which can be matched against the complete text of your link. And this is how you can use your partial link text or the link text. The next ID is by name. So locating elements by name is very similar to locating by ID. Just that your attribute, instead of using an ID, you're going to use name in this case. Now if you look at the same example of say Facebook, we identified this email element using its ID. You can also locate the same element by using the name attribute, which is also unique in this case, which has a value called email. Tag name, that's the next identifier. So locate element using tag name of the element. Now say if you want to identify all the elements on your web page which are of type button. So that you can do by using the tag name as button there. For example, again on your Facebook page, I know that there is a single button here which is of type button and which has a tag as button. And this is the only button which is available on this page. So if I want to access this particular element, I can simply use a locator technique called tag, which is button in this case. Next locator, class name. So locate an element using its class name attribute. So you can use this identifier only if you find that a class name is unique for a web element which you want to work with. Class names are sometimes unique. A web element can also have multiple class names, or even you will find some elements which has no class name. So depending on what is available in the attributes, you can use this class name for identification. So example the shown on your screen here where it says find element by class name input text. Basically this is going to list out all elements on your web page which has a class name called input text. The next identifier is by XPath. Now XPath is a language used when locating XML nodes. What is XML? Extendable Markup Language. It can access almost any element, even those without any class names or even ID attributes. So whenever you do not find a unique attribute for ID, name or class name, you can construct an XPath to create a unique identifier for that particular element. Now, for example, on this Facebook page, if you observe here, there is a label here called create an account. So if you inspect this particular label, it has no attributes other than a tag called spam. So if you want to identify this particular element and say display it, this is one of the ways to do it is through XPath. CSS selector. So CSS selector are string patterns used to identify an element based on the combination of either the HTML tag, ID, class or any other attributes. Locating by CSS selector is little more complicated than any of the previous method. However, the advantage is CSS selectors work much faster than the XPath. The performance of your test scripts is much better when you use CSS selector than any other locating technique. Now again, as an example, if you see the Facebook again, you can identify the same email here, right? I used an ID here or a name attribute here to identify it. So assume that if you did not have any of those things, or if you want to use a CSS selector here, you can still do that by using this syntax. This is how you use the CSS selector to identify an element. Question 8. What are the types of weights supported by WebDriver? Now, before even you answer this question, you should know why do we need weights. In Selenium, weights play a very important role in executing test cases. Most of the web applications are developed using Ajax and JavaScripts. So when a page is loaded by the browser, the elements which you want to interact may load at a different time intervals. Not only this makes it difficult to identify the elements, but also if the element is not located, it will start throwing element not visible exception. And how do we resolve this? By using the weights. So there are 3 different kind of weights available in Selenium. First one is the implicit weight. The implicit wait tells the browser or your WebDriver to wait for a certain amount of time before it can throw a no such element exception. Now the default setting is 0 for this. Once we set a time, what WebDriver does it will wait for that time. Say if you have mentioned 10 seconds, it will wait for 10 seconds until it finds the element, and even in the 10 seconds it is unable to find that element. Only after that it throws an exception. Now what is the syntax of this? Implicit wait is, this is the syntax of this, where you use driver.manage timeouts, implicit wait, and there is a timeout value, say 10 seconds, and the unit, whether it's in minutes, seconds, or milliseconds is what you can mention. Implicit wait is applied globally to all the elements, which means it is available for all the web elements throughout the driver instance. Implicit wait is defined only once and it will remain same throughout the driver object instance. Now let's see what explicit wait is. So explicit wait is used to tell the WebDriver to wait for certain conditions before throwing an element not visible exception. It is defined to wait for certain expected conditions only. Now these expected conditions can check whether the element is displayed on the web page or not, or can be clicked or not. So any kind of conditions you can mention there. So these are called as conditional waits, and they are applied on a web element, on a single web element, unlike the implicit wait, which was kind of applied globally to all elements. It is definitely recommended to use this explicit wait when your elements are taking longer time to load, and also for verifying the property of the elements, like say visibility of the element located, element to be clickable, or element to be selected. Then we have fluent wait. Now fluent wait is used to tell the WebDriver to wait for a condition that is very similar to the explicit wait, as well as a frequency with which we want to keep checking the condition before throwing the not visible exception. So fluent wait is used to define the maximum amount of time you want the WebDriver to wait for a condition. Then if you look in the syntax, then there is polling every second. So polling every, and you give a timeout. This could be like 5 seconds. So start polling to see whether the web element is available or not. Say once in 3 seconds, once in 4 seconds, depending on your use case. And then dot ignoring. So you can also try to ignore specific type of exceptions while waiting. Now for example, such as no such element exception, which is sometimes thrown when searching for an element on the page. So you can mention even that here. So fluent wait takes 2 parameters. One is the timeout value and the polling frequency. So when we have web elements which sometimes are visible after a few seconds, or sometimes it takes more time than usual, like we have Ajax applications as an example, we can set a default polling period based on our requirement, and then as I said, you can also ignore some of the exceptions while polling this element. Question 9. Mention the types of navigation commands available in Selenium. So WebDriver provides a basic browser navigation commands that allows the browser to move forward, backward, refresh, and using the browser history. And this is done using some of the driver.navigate methods. Right? So these are some of the commonly used navigation methods. First one is navigate to. So this method loads a new web page in the existing browser window, and it accepts string as a parameter and returns nothing. So it's a void. So the URL you mentioned here needs to be a fully formed URL. Driver.navigate.refresh. So this method refreshes or reloads the current web page in the existing browser window. It neither accepts anything, so there is no value passed, or it returns nothing. Forward. So this method enables the web browser to click on the forward button in the existing browser window. Again, this has no arguments to be passed, or it returns nothing. Driver.navigate.back. So this method enables the web browser to click on the back button in the existing browser window. Again, this returns nothing, nor it needs any argument. Question 10. What is the major difference between driver.close and driver.quit? So this is again a very important question and pretty confusing also sometimes. So Selenium WebDriver provides two methods for closing the browser window. One is browser.close and the other one is the browser.quit. So you might think to use them interchangeably, and that's what everybody thinks, that both anyway does the same function, so it can be used. However, it is not so. Both are two different methods. Now driver.close command is used to close the current browser window which is having the focus. And in case if there is a only single browser window open, then calling this driver.close actually quits the complete browser session. Now it is used when you're working with say multiple browser tabs or windows and you want to just close one of them which is in focus in the test, right? Whereas the driver.quit is used to quit the complete browser session along with all its associated windows, tabs, pop-ups and everything. So when do you use browser.quit? It is best to use driver.quit when you no longer want to interact with the driver object along with all its associated windows, tabs and pop-ups. Generally, it is one of the last statements of your automation scripts. So in case you are like working with Selenium with TestNG or JUnit, we usually call this driver.quit in the after suite, that is at after suite method of our test suite. Thus, by doing that, we close the complete browser session at the end of the test suite execution. Now, let's look at some intermediate level questions. Question 11. How to type in an input box using Selenium? So Selenium provides a method or a command, you can say, to insert value into any of the input box. And this command is called as a sendKeys command. So sendKeys is a method available in a web element. Now this is how you use the sendKeys. So here is an example. So first you need to find the element using any of the 8 locating techniques. And once you find the element, in this case which is an email field, you need to call a method called sendKeys. SendKeys takes an argument which is of type string. So you can pass the value which you want to pass to the web element. So in this case, you will be passing a Gmail ID or any ID which will be your email ID here. And then similarly, you do it for your password field. So first you find the element password and then you send the password using SendKeys. This is a very simple method to use. Question 12. How to click on a hyperlink in Selenium? So whenever you are testing an e-commerce application, you are going to find a lot of hyperlinks on your web pages, which you will obviously need to test. Now Selenium provides 2 locating techniques using which you can identify these hyperlinks. And using these is what you need to operate on the hyperlinks on your web pages. So one is using link text and other one is using partial link text. So using link text, you give a complete text in the link text. That is, if you look at any e-commerce, right? Let's say Amazon.in. Let's go to that website and see what it means. So in the Amazon.in, if you look at some of these hyperlink text called today's deals or Amazon Pay or sell or customer service, if you inspect this element, you will see that this is associated with a link text which is called as today's deal along with its href and of course an anchor tag. So one way of identifying this link is to use this complete text which is today's deal. Also, there is another way by using partial link text. For say example, you have a link text which is pretty long and you do not want to use this complete text. Instead, you can use the locating technique called partial link text and give a partial text from that. In this example, instead of giving the complete customer service here, you can just say use a customer or you can just use service as your text. Only thing what will be required here is this has to be unique on this page. There shouldn't be 2 elements which would have this text which you are going to use. So let's quickly see this in action. How do we use this link text and partial link text? Now we will be using the same example of Amazon.in. So my use cases, first I will click on this today's deal and after a sleep of 2 or 3 seconds, I will also click on customer service. And I'm going to achieve this one by using link text. So if you see in this program, so I have this method written which is going to click on today's deal and this is using a locating technique link text. And then I also have another method here. By using partial link text, I'm going to be clicking on the customer service link, right? So let's see how this works. So I'll just go ahead and execute this. So this launches the Amazon.in. And the first thing what we are doing is it is going to click on today's deal. All right, that is done. And then it will click on the customer service link, right? So this is how you can achieve clicking on the hyperlinks in your web applications. Question 13. How to scroll down a page using JavaScript? This is a very important question and usually this gets asked quite often in the interview. You should know that you can run JavaScripts through Selenium, and Selenium provides a way to do this. Selenium provides an interface called JavaScript Executor, and this helps in executing any kind of JavaScripts through the Selenium WebDriver. So this JavaScript executor, it has basically two methods. One is execute script and the other one is execute async script to run the JavaScript on the selected window or on your current page. But why do you need this, right? So if you're answering this question, you should also have a background that why at all this is required. Because sometimes you need to perform certain functions which cannot be done using the locators, what has been provided. Like say scrolling down the web page itself. Also, sometimes you will see that you are unable to even identify some web elements using all the locating techniques which is made available by Selenium. So in such situations, what you can do is you can directly write a JavaScript and execute it using this JavaScript executor. And if you look at it, the syntax is something like this. So it says JavaScript executor, JS is equal to JavaScript executor and driver. Now, if you look at this, JavaScript executor is an interface. That means you cannot create an object of it, and hence you typecast it to your driver object. Now, how do you do this? Now, first thing what you do is you launch your web application on whatever web application is under test, and then on that current window, you call this particular execute script method using the JavaScript executor. And then you can perform any functions here. In this example, we are seeing a function which is scrolling down vertically. So this function takes in attributes or arguments like x coordinate and the y coordinate. Now in this example, our x coordinate is 0 and y coordinate is 1000. That means when this command gets executed, the page is going to get scrolled down vertically by 1000 pixels. So why don't we just see this in action? So let's go to another program here called the scrolling tester Java. So basically what I'm doing here is I'm going to be logging into amazon.in, and then I will show you how to scroll down by 600 pixels. So it's a very simple code to write. You launch your application, then you create your object of JavaScript executor, right? Actually you typecast it to the driver, and then you just use an execute script command or a method. This you see is your actual script which gets executed, which says windows.scroll by 0,600, which is x coordinate and y coordinate. Let's go ahead and execute this. So an amazon.in is launched and you should see the screen scroll down. Yes, there we go. So it just scrolled down by few pixels, and that is 600 pixels what we mentioned. See, I could scroll back again. And that is how you can achieve scrolling functions. And when do you usually use this? Say if you have a very long web page and you want to go and identify or do some operations on the web element which is probably available to you towards the end of the page. And that is when you can use some of the scrolling functions. Question 14. How to assert the title of a web page? Selenium WebDriver provides WebDriver methods, and one such method is called getTitle. So what getTitle does is it fetches the title of the current page. How to use this command? GetTitle returns a string which is nothing but your title of your page. That means you need a string variable in which you can store this value. So what you do is you define a string variable like it is defined in this example to store your title. And then you execute this command driver.getTitle, which is going to fetch the title, and that value gets stored in your actual title. Once you get the title, you can do any operations with that. In this case, what we are doing is we are trying to verify the title. There are two ways which you can verify that. One is using an if-else statement where you compare your actual title with the expected title, or alternatively, you can also use assert statements here. Right? So Selenium provides us assert statement. So using assert, you can validate whether your title of the web page is as expected. Question 15. How to mouse hover over an element? In automation, many times it is required to perform some action on the element which gets visible only on the mouse hovering on those elements. Now in Selenium, action is a class which we can use to achieve this functionality. So action class is defined in a package called as selenium.interactions. This has a set of APIs to emulate complex user gestures. It helps in building the patterns of action and then perform that action on a web element. Now this action class provides a rich set of APIs, like so for mouse events and even the keyboard events. So say for to perform any kind of mouse event, it provides a method called move to element. Now in this example, what you do is you initiate an object of mouse class and then use this move to element method. And what it does is the element is scrolled into the view first, even before the move operations happen. So you could have multiple actions, like here in this example we are just using move to element, but also you can, if you want to do a drag and drop operation, you can still have that. So in such case where you have multiple actions like a drag and drop, then you use a method called build along with this. So you say actions.move to element dot build and then dot perform. So dot build method is called before the perform method, and what it does is it generates the composite actions which has all those multiple actions which you want to perform on a web element. Then after the building action is done, you call a perform method which actually performs that action on your web element. And this is how the move to element method of the action class is used. Why don't we just see that in action? Let's go to our Eclipse here, and I have a mouse hover test written here. So let's say we go to amazon.website. So in the Amazon, if you go to the shop by category, you see that? So the moment I mouse hover it, it is going to give me this drop down list. So for me to select any element from this, my first action on this web page should be to go and just hover my mouse over this web element called shop by category. And that's exactly I'm going to achieve through my automation. Now here in my methods here, what I have written, I have said, okay, first launch your website, which is amazon.in. And then I'm finding that element which is shop by category using an XPath. So you could use any available locating technique to find the element first. And then I instantiate an object of actions, and then simply I'm doing is I'm using the method move to element, and then I'm just going to say perform. That means my mouse would actually get moved or hovered onto that particular element. Okay, so let's see this in action. So I'll just execute this test case. Okay, so amazon.in is launched, and now we should see, yeah, the mouse actually moved to shop by category, and because of that we got this drop down list. So, and this is how you can achieve your mouse hover functionality. Question 16. How to retrieve the CSS properties of an element? Now CSS is nothing but cascading style sheets. It's a style sheet language used for describing the presentation of a document written in your markup language. It basically describes your HTML elements as how they need to be displayed on the screen. It's basically the look and feel, like your font size, the width, height, color, and so on. So it provides a special and easy way to specify various properties of the element. Now why do we need this? We need to use a special method called getCSSValue to retrieve such CSS properties of web element. Why? Because we already have a method called getAttribute, which can retrieve the value of the attributes, right? However, the getAttribute method can only retrieve those properties where the attribute and its value are mentioned in your DOM. And hence, all this font size, color cannot be retrieved through the getAttribute method. And that is why we use the getCSSValue. So basically it works like your get method, and you need to provide the attribute which you want to fetch using the getCSSValue. So in this example, what we are trying to do is we have a web element called the email ID, and of that we are trying to fetch the font size. So let's again check this in action. So if I go to my web page here, let's close this. So if I go to my Facebook, and if I inspect this particular element, which is the email ID, and on the right, if you see, there are multiple other attributes of that element you see, right? So you see the background color, you see the color here, then you see something called as font size. And say for example, we want to retrieve the font size of this particular web element. And you will also see on the left where you're seeing the DOM here, you do not see that font size anywhere as an attribute and its value here. And that is why I cannot use the getAttribute method to retrieve it. Now instead of that, what I'm going to do is I'm going to use the getCSSValue and use this font size for that. So let's go to my Eclipse. I have a method written here where I log into the Facebook, and then I'm going to first find that element which is by ID, and I'm going to retrieve the CSS value, and I'm just simply printing it on the console. So if I execute this, so it's going to launch the Facebook. And since I'm not going to do anything on the Facebook web page as such, let's go to my console here, because this is where I'm expecting the output. So here it has given me an output in the console saying 12px, which is nothing but your actual font size, what you see here in your HTML page, right? And this is how you can extract your CSS properties of any web element on your web page. Question 17. What is Page Object Model, popularly known as POM? Page Object Model is a design pattern that helps create object repositories for web elements. So writing Selenium test cases without, say, using any patterns may lead to code duplicacy, and also the code becomes unmaintainable after some time. And say if you have web element locators which changes over time, then you will have to go through the entire code base to make all the required changes. So under this model, for each web page in the application, there should be a corresponding page class. And this page class will have all the web elements of the web page, and also it contains the page methods which perform operations on the web elements. And the verification steps required in your test cases are the separate test cases itself. They are not combined in the same class. Now the tests that use the methods of this page object class whenever they need to interact with the UI of that page. The benefit here is if the page UI changes, then the test need not be changed. Only the code within this page object class needs to be changed. That is, you go and just change the web elements or the locators of the web elements only in one place, which is your page class, and not in any of your test classes or not test classes. So how does this POM help? So it makes the code more readable, maintainable, and reusable. So there are two ways you can implement a POM or a page object model. One is done using the page factory, which is offered by Selenium, and then you can also achieve a page object model without using the page factory, right? Using directly the objects and the classes. Question 18. Can CAPTCHA be automated? This is again a very favorite question of the interviewer. CAPTCHA is a security feature that prevents bots and automated programs from accessing sensitive information. Yes, and CAPTCHA cannot be automated. You will see that there are many applications today who have CAPTCHA. Why? Because it's a security feature. It is a concept to differentiate between human and computers. The idea of CAPTCHA itself is to prevent any automated process or a robotic process to do any kind of actions. And say if you're going to automate it, then the entire idea of having the CAPTCHA is lost. So you should never attempt to automate it. But then how can you handle this then? One, either you can ask your developers to disable it in the test environment, so that you can test the whole application without having to hit on this CAPTCHA. Other way of doing this is you can use static data for your CAPTCHA so that you can hard code that value in your test for the time being. And then since your application has CAPTCHA as one of its functionality, if you really need to test that, you can just test that separately as a manual testing itself, but not automate it. Question 19. How does Selenium handle Windows-based pop-up? Selenium is an automation tool for automating web applications. It cannot handle Windows-based application. However, we can use tools like AutoIt and Robot class along with Selenium to handle such pop-ups. So what are these tools? Robot class is a Java class which along with Selenium can simulate your keyboard and mouse events. It also helps in upload and download of files and also to manage the pop-ups. So wherever you have a requirement of doing a file upload operation, in which if your native dialog box opens up, then one of the way to handle it is using Robot class. Other tool which is available for us is the AutoIt tool. It is a freeware, and what it does is it uses a combination of your mouse movement, keystrokes, and window control manipulation to automate any such task which is not possible by Selenium WebDriver. And again, this AutoIt tool can be integrated with Selenium, and thus you can achieve the automation of native window-based pop-ups. Question 20. How to take screenshots in WebDriver? Take screenshot interface can be used to take screenshots in WebDriver. So Selenium provides us this interface for managing our screenshot operations. Now screenshots are desirable for bug analysis. So Selenium can automatically take these screenshots during your execution. You know that it is very important to take screenshots when we execute the test scripts. Say if we have a huge number of test scripts running, and if some of the test case fail, we need to check why these test case failed. So using the screenshot functionality, it helps us debug and identify the problem by looking at those screenshots. So WebDriver has this built-in functionality to take the screenshot across the page, and it's pretty easy to use. Take screenshot interface is used to capture the screenshot during the execution. Now this interface has a method called getScreenshotAs, which captures a screenshot and it also stores in a location specified by us. So let's take an example of our Facebook page and say we fail a particular test case on the Facebook application. And then let's see how we take a screenshot at that particular moment when the test case fails. So let's go to the Facebook page first and let's understand the use case. So in this Facebook page, say if I am signing up on this page, I need to enter all this field. Now as a part of demo, what I will do is I'll just enter the first name and the surname and I will click on the sign up button. With this test case, it should basically not sign me up, rather it should give me some error saying that you need to enter all the fields. And at that minute, we are going to take a screenshot. Okay, so that's our use case. So let's see how do we achieve that. So if I go to my Eclipse and let's say we go to my screenshot test.java, I have a method written here. So, and these are the operations which I just described, which I'm doing it here. So I'm going to just send keys, my first name to the first name field, second name into the third name field, and then I'm just going to click on the sign up button. Now there are few things required for us to do before we use the take screenshot interface along with its method, which is the get screenshot as. So I said that this method stores the screenshot taken in a file. So that means I need to provide it a file name and also a location where it needs to be placed. So in our demo here in this test class, what I have done is I've created a folder called screenshot in the same project directory. And then I am giving it a file name called fblogin.png. So that means after the screenshot is taken, it is saved in a file called fblogin.png and then it is stored in the location screenshot folder. And these are the simple file operations of Java which I use to achieve this. So let's execute this and see how this happens. So right now I have the screenshot folder and it's an empty folder. So after the execution, I'm expecting that this particular file would get created. So let's see that in action. So I'll go ahead and execute this Java program. Okay, so we have launched the facebook.com and then I entered the my first name, second name, and it has also clicked on sign up, after which it has given all this red marks here. And now this is what I'm expecting in the screenshot. So let's go back to our Eclipse. I will refresh this folder. So I'll say right click and refresh. Okay, I have this file created. So let's open this file and see. Right. So do you see this? This whole image has been captured. So now as a tester, if at all this test case fails for me, I can always open this PNG file and see what actually happened. And I can debug my test case. So this is how you use screenshot functionality in Selenium. Level questions. Question 21. Can you type in a text box without using send keys? So this is a very favorite question of any interviewer. So you should know that sometimes on an IE browser, whenever you use the send keys command, it is pretty slow. So some of the performance of some of your test cases gets impacted. So you need an alternative way to use instead of using the send keys function. And one such alternative is using JavaScript executor. So Selenium provides an interface called JavaScript executor, and this helps in executing any JavaScripts through your Selenium WebDriver. So you can do any kind of function using this JavaScripts. And one of the functions which we can do is the send keys kind of a function. Now how to replicate a send keys function using JavaScripts? So let's see an example here. Now since this JavaScript executor is an interface, you cannot create an object of this interface. So what you do, you typecast it to your driver object the way it is done here in this example. And then you use document.getElementId to get the actual element on which you're going to perform the operations of sending the keys. Now what is this document? So it is an object, right? So this document, it's an object that represents your HTML document which is displayed in that window. And this document object has various properties that refer to other object which allows you the access to modify any of your document content. So the argument which you're passing to the Java execute script is nothing but your JavaScript. Now this JavaScript uses the document object to identify your element and then send the value which you need to send to that element. So let's see this in action as how it works. So let me show you a small program here. Alright. So I have a method here wherein I'm trying to identify the email field of your Facebook page. So if this is your Facebook application, this is my email field. And instead of using send keys here, I'm going to pass an email value to this. And how am I doing that? Using a JavaScript executor, right? So if I execute this particular Java program, it is exactly going to do the same function what I would do otherwise using the send keys. So let's execute this and see if I can see my user's ID email in the Facebook application. So the Facebook application is launched and there we go. So this is the value which I have sent using my JavaScript. Okay, so this is how you can use a JavaScript executor to replicate a send keys method. Question 22. How to select a value from your drop-down list in the Selenium WebDriver. So select class is a Selenium WebDriver. It is used for selecting and deselecting options in your drop-down list. The objects of select type can be initialized by passing the drop-down web element as a parameter to its constructor. Like in this example, I'm saying select drop down equal to new select of test drop. So test drop is nothing but the web element which I have identified using any locating techniques. After you create the select object, then you have 3 different methods available for actually selecting your methods. And what are these methods? One is select by index. Now the index starts with 0 in the list. So you can select any element from your list using the index ID. And then the second one is select by values. So this is used to select an option based on its value attribute. Select by visible text. So this is an option wherein you can select a particular list item or an option based on the text displayed in the option. So that means whatever text you can see on your drop down list is what you will use it to identify that particular element. So let's see the demo for this. So I have again a same Facebook application which I've considered here for demo. So if you go to our Facebook application first, you know that there is a drop down menu here. Now this drop down is for selecting your birth date. This has a day values which you can select, the month values, right, and the year. Now what I have done in my code is, first thing is I've identified all these drop down boxes using I'm using mostly the ID locating technique here. So you can use any of your choice. So once I identify the element, I created the select object class for each of this. And I pass that web element to the constructor of the select class. So now my select element or the object is ready to use. So my next step, what I need to do is I need to go and select the actual dates. Now in this use case, what I want is I want to select a date which is 10th June 2005. That means on my select drop down of the day, I should be able to select the day 10. Now this I'm achieving by using select by value. And then I'm selecting the month based on the index, which is the index in this case is 6, which will select the June for me. And then the third one I'm trying to select it by visible text, wherein I'm selecting the year 2005. So when I execute this program, let's see how the date selection happens. Okay, there we go. So it selected the 10, the day 10, the June month and the 2005. So this is how you use select objects in Selenium. Question 23. What does the switch to command do? So switch to command is used to switch between windows, frames or even the alert pop-ups within your application, right? So there are multiple things which you can do with switch to. Now, sometimes in your web application, say when you click on a button, it opens up a completely new browser window, or you'll also see it opens up another tab in your browser. Say for example, let's look at one of this application which I have. Let me go to my browser and say I launch hdfcbank.com. All right, so this is my application, say, which you want to test. Now when you launch this, first thing is I see this advertisement pop-up which comes up, which is right now an unwanted pop-up. So right now I'll just close this. And now if I want to enter this HDFC Bank application, first I need to do a login. So if I click on this login button, see there is a new window which opens up. And I need to go and operate into this window. So for any further operations I want to do it on this web page, I need to switch to this window and then say I want to click on continue to net banking and then continue with my use case. So now in this application there are 2 windows open. One is your base window from where we actually logged in, and after I clicked on the login there is a new window opened up, right? So this is where your switch to command will help us to switching to this particular window to do any of the operations on this web elements present on this window. Okay, now let's see how do we actually do this. So in order to do this, first you need to get the handle of the window by using a command called driver.getWindowHandle. All right, so now when you use driver.getWindowHandle, what you get is a unique alphanumeric value which is an identifier for that window. And once you get this, you use a command called driver.switchTo.window and you pass that handle which you have fetched previously. And this command will actually switch to the current window which is in your focus. Now you'll also come across a case where there are multiple windows open. Right now the example what we saw, we just had a single window. But say if you, whenever you launch an application, say there are multiple windows which are open. So in such case you can use something called as get windows handles. Right? Now get windows handles, what it does, it picks up all the active windows at that point of a time. And using a for loop, you can read into every handle and then you do your operations specific to your window handles. Also, there is another way wherein you can switch back to your parent window. So if ever you want to switch back to your parent window, you have to use the same command driver.switch to, and the handle what you need to provide here is your parent handle. Alright, so this is about windows. Then I also said switch to can be used for your frames. So what are frames? Frames are usually used to divide your web application or your web page or on the same domain into various different windows or sections, right? So for us to operate on elements which are in different frames, we need to first switch to a particular frame and then use the web elements on that. So the same command we'll be using. Now instead of window here, I would say driver.switch to .frame. Similarly, even the alert pop-ups can be handled using the same command. So in the case of alert, what you need to do is you have to say driver.switch to .alert. Question 20. How to upload a file in Selenium WebDriver, right? A very important concept in Selenium WebDriver. We know that Selenium WebDriver is designed for automating web application, right? And file upload is a very common scenario which we get with every web application which we are working with. Now there are two ways to do a file upload operation. One is using the send keys, which is the simplest method, and the other way is using robot class. Now there are certain prereqs required for you to work with the send keys option. Now if you are using the send keys option, what you basically need to do is you need to type in the complete path of the file along with the file name, right? In the file select input field. Now this element where you're going to enter your file name should have certain attributes. One of the attributes is it should have the tag as input, right? And also it should have an attribute called type which should have a value of file. Only then it is possible for you to enter a file name and upload the file. Okay, that is by using the send keys method. Then the other way is using robot. Now when is that we need to use robot? Whenever you have an application and in your application, usually for your file upload, you have a button which says upload a file, and when you click on that, it opens a new window. And this window is your Windows Explorer window or a Finder window, depending on what operating system you're working. And these are the native windows. And we know that Selenium WebDriver directly cannot handle the native applications. So in such case, the robot class helps us in managing these native windows. So what happens in the robot classes? It helps you manage your file upload dialog box by simulating all the actions required for selecting a particular file from your dialog box, and then you go and upload them. Alright, so this is the example of using the send keys. Question 25. How to set browser window size in WebDriver? So you can either maximize the window or set it to a certain value. Now to do this, you use a simple functions provided by driver.manage. One of the functions using driver.manage is driver.manage.window.maximize. Now this command maximizes the current window. And say you want to set a particular window size rather than maximizing it. And then for that you have a command called driver.manage.window.setSize. Now this set size takes an argument of the type dimension class. So this is basically when you create a dimension class, you are passing the size of the window which you want to create here, right? So we use the dimension class, define the new dimensions of the window, and then pass the object of this dimensions to the set size method. This is one way of doing it. We also saw that using JavaScript executor, we can do any kind of functionality. So if you want to minimize or maximize or set a different size to your browser windows, this can also be done using a JavaScript. Okay, let's see a quick demo on how do we use this driver.manage.setSize or the maximize command. So let's go to my Eclipse here. So I have this method written here. So I have two methods. One method where I'm saying I'm going to maximize the window. This particular command is where I'm saying driver.manage.window.maximize, and I'm launching a Facebook application. So first let's run this particular method and see how our browser window behaves. So I'll just say execute this. So now you will see the whole window, your browser window is in maximized mode. So now from here, I'm going to execute the other set of lines here, using which I'm going to set a certain size. Now I'll just comment out these two lines, and then these are the two commands which I'm going to use, right? So here what I've done is I've defined an object of the class dimension, and I've used 600 600, which is the size of the window which I want it to be. And then using the set size, I'm passing this dimension object to the set size method. Now let's see how do we look at this browser window now. Did you see that? So it was at a certain size and it just shrunk. It shrunk because I have used a smaller size window. Question 26. When do we use find element and find elements? Now find element, you can use this command to access any single element on your web page. And what does it return? It returns an object of the first matching element of the specified locator. And this is the most common command what we use for working with every web element on the web page. What is find elements? Find elements is used to return a list of web elements, right? So each element which it identifies is indexed with the number starting from 0. It's just like an array. I'll show you an example of that so that you can understand it better. So let's go to my Eclipse here, right? So if you look at this locators.java, I have different elements which I have identified using different locating techniques, right? So for that I use a simple command called find element. Now say I have a use case, right, wherein I want to fetch all the web elements who have a class name starting with the text input. Let's see what that is. So if I go to my Facebook application, if I try to inspect this, say, first name, right? So I'll say inspect element. Now here if you see, this particular web element has a class name starting with text called as input text. Likewise, there are many elements here, like even the surname, if you look at it, it has a class name starting with input text. Okay. So if I have a use case like that, where I want all the web elements on the Facebook page who have the class name starting with the text input, if I have to do that, that is when I say I'm going to use the driver.findElements. So I say driver.findElements, I give an XPath which is going to pick up all those elements which has the class name starting with input. This is my XPath expression. Once I get all the elements, what am I doing? I am going to store it in a list array. Once I have all these elements created, it's in an array, I'm just going to traverse through the array using an enhanced for loop. So in this program, in this test case, I'm just picking each and every element and printing the attribute ID of each element. So if I execute this now, we should see all the elements on the Facebook page which has the class name starting with input, and we should see all the IDs of that. So this is what we are getting. So you are around getting 9 to 10 elements it has picked up, and all of them have the class name starting with input, and these are their different IDs. Question 27. What is pause on exception in Selenium IDE? So pause on exception is a new feature of Selenium IDE. It is one of the brilliant debugger function which this new Selenium IDE provides us. What it does is it enables us, or when this particular option is enabled, the execution of your tests pauses if at all there is any exception which occurs in your test scripts. And because of this, what you can do is you can go and handle that error by, say, changing your command in the script and then continue your test execution. So this helps in debugging your code pretty well. So whenever there is an exception, say for example, an web element which you're trying to identify has a wrong identifier or it changes on your web page, then you can correct that command which caused the exception and then resume the test execution from that point onwards. So let's look at a simple use case and see how exactly this works. So for example, let's go to my browser here. Okay, so I have a simple use case here where I want to log in into Facebook using my email ID and password. And what I have done is I have created a script or recorded a script using my Selenium ID. So these are all the steps which it has, wherein it logs into the Facebook account, then it clicks on the email field, enters the email, this is my value which I'm passing, clicks on the password field, enters the password, and then clicks on the login button. Now this is a clean test script and all my web elements are correct here. So whenever I'm running this test script is going to pass. Now say as an example, say this particular element, which is my password element, say this ID changes. So now deliberately what I'm going to do, I'm just going to give a wrong ID here. So if I give a wrong ID and if I execute this test script now, it is going to throw an exception at this point. So let's do that. So it's going to throw an exception, but now since I want to use that pause on exception feature, what I do is it's available here. It says pause on exception. By default, it is switched off. So when you select this, that means this has been switched on. And now if I execute the script, this is going to come into a debug mode at this point where my exception is going to be thrown. So let's see that. So now I have changed this ID to a wrong ID. So I'll just say go and run this current test. So let's see how it operates. So let me just bring this side by side so you can see here. So it has entered the email, and if you look here in the console, it is saying trying to find the ID for which I've given PA and 4S, which is a wrong ID. So it will look for some time whether it can find an element with this particular ID. So let's wait for it to throw the exception. There we go. So now it tried enough, and actually that step has failed, and there is an exception saying that that particular web element is not found. However, my test case or the test script did not exit. It has come and paused, and it has entered into a debug mode here. Paused and debug. Now as a tester or an automation script writer, what I can do here is I can simply go and correct this. Now I know this is my correct ID. Once I correct this, I can execute the rest of the script right from this point. So now I have this option here. If you go here, it says resume test execution. So I'm just going to click on that. So it is going to go ahead and enter everything here. If you see here, I entered email password, and in this test script, what I'm doing is I'm entering my first name and my surname instead of clicking on the login button. So it went ahead, and if you look here, it says FB test completed successfully. This is how the pause and exception feature helps us. Question 28. How to log in into any website if it is showing an authentication pop-up for username and password, which will be something like this. So this is a typical authentication pop-up which you normally see when you're dealing with some web application, right? And to handle them, we use something called as an alert class, and alert class comes with a method called authenticate using. Basically, by using this method, what we are trying to do is it helps us skip the basic HTTP authentication box. So how do we handle it? It is handled exactly the way we handle any kind of alert box in Selenium. Now in this example, first what we need to do is we need to create a wait object using an explicit wait. Now this wait is for what? It is for the alert to pop up. So we basically wait until that authentication alert pops up and set the conditions in this explicit wait for as alert is present. So that means you're going to wait until your authentication pop-up is seen on your screen. And then once you have that authentication pop-up which is on your screen, that is when you need to go and handle it. Now to handle it for your alert class, you're going to call a method, as I said, using authenticate using, and to this you pass a parameter. Now this parameter has to be your username and password. However, the way the parameters are passed here is using a class object called user and password. Now this user and password class, it is a part of Selenium security package. Alright, and this is implemented from an interface called credentials. So you create this object of class user and password using the authentication information which you have, and then pass this as parameter to your method called authenticate using. And this way you can handle your authentication pop-up. Question 29. What is the difference between single and double slash in XPath? A very important question, and it's a very important thing for each of you to understand. Single slash is used to create an XPath with absolute path. That is, the XPath would be created right from the starting node, and the starting node is /HTML. And the double slash is created, or it's a XPath with relative path. Now relative path, this XPath would be created using any starting location or anywhere within the document. For example, I could start with a div tag, wherein if I mention double slash and div, so this is going to be treated as a relative path, and whatever conditions I'm going to give, it is going to try and match those attributes with this tag, right? This is called as a relative path. So why don't we just go and take a look at how do we identify an element using a relative as well as an absolute path. So if I go back to the same application of the Facebook, this is my Facebook application. Now I have this crow path installed, which helps me in identifying XPaths of an element. Now say I want to try and see what is the XPath of my element first name. So in the inspector tool, I can see that it has a tag input and it has a long class name and it has multiple attributes which I can use to identify this element. So if I go to my crow path and again try to match this element, So if I just hover my mouse here, now here you can see this scroll path gives me both the path. One is the relative XPath and one is the absolute XPath. Now look at the big difference between these two. Now relative path was as simple as using a // input, which is the tag, and an attribute called ID. We are able to identify this particular element. Same thing if you want to use an absolute path, and if you see here, it will start right from the /HTML, which is your starting node of your HTML page. And then it traverses down looking into each of the parent and child under this until it found this element input. Right? So this is absolute path. So you can use either of these paths to identify your elements. Question 30. How do you find broken links in Selenium WebDriver? Now, HTTP is designed for what? To enable communications between your clients and servers. And if you know, there are few commands like get, put, post. Now, get is used to request data from a specified resource. Put command is used to send data over your server. And post is used to send data to the server, right? Now, while using these links and trying to figure out if the link is valid or not, what you can do is you can use something called as head requests. Now, what are head requests? Head requests are nothing but they are something like a get request, but they do not have a response body. And usually this is used for checking that what a get request can return before actually making a get request. Like say, before downloading a large file, you would send a head request before sending the complete get, just to know whether the link which is provided for downloading a large file is a genuine link or not. And then looking at the response code is what you decide that. So how do we do this programmatically? Now Selenium provides something called as HTTP URL connection class, which has some methods to send HTTP request and to capture the HTTP response codes, like the ones which you see it on the screen. So if we have to see how do we do that, now first thing, the logic behind how do we get this broken links is you get all the URLs on your website first. After getting all the URLs, now how do you get the URLs? By using the tag A, like it is done here. So once you get the complete list of all URLs, you also check for a non-null or a blank ones. That is one kind of a check which you can put. After that, you create an HTTP connection object with each of the URL. And you open the connection of the URL and you send the request. Now this request, whatever you're going to send, you are going to send the header request to just to get the head and not the complete get request. Now, only thing what you're interested in getting a response code. So once you get the response code, what you have to do is you have to check the response code against all your response code. Now typically when you're checking for your response code, any response code above 400 is treated as a client error. Rest all the links below 400 are all the valid links. So here if you see 404, you have a response called as link not found. 400 is a bad request, 401 is unauthorized. So you can do a simple check there where it says if your response code is above 500, then that particular link has an error and that is probably going to be an invalid link. So let's see that in action as how exactly the code is going to look and how do we achieve that. Now I have a test case written here called brokenlinks.java. Now here what I'm doing is I'm logging into facebook.com and then I'm fetching all the elements with the tag A. Now when I say I'm fetching all the elements with the tag A, that means I'm going to get all the href element from the page. And once I get that, using a for loop, I'm going to inspect each and every URL what I'm going to fetch. As I said, my first check would be to see if it is a null or is it an empty. If I find an empty or a null value in the URL, I'm just going to ignore that and continue the loop. And this is where I actually do the connection with my URL. So I create an HTTP URL connection with the URL, which I have picked it up from my website. Then I do this, I send a request here, the head request, to get a response code. So once I get this response code is what I put a if-else statement and check if my response code is greater than or equal to 400. So if I find that if my response code is more than 400, that means this particular URL link is broken, and that is how I identify. So once you identify a particular URL which is broken, you can make use of that information, share it with your developers and get it fixed. So let's go ahead and execute this. So in this test case, basically what I'm going to do is I'm just printing out all the URLs and I'm printing the ones which are valid and ones which are broken. Since it's a facebook.com website, I do not have any broken URL, but this is just a logic of how do we find a broken URL. So if you look here, there are a lot of websites which is getting listed which says is a valid link. So that means it is getting a response code which is more than 500. So this is what we saw in the demo, as how do I iterate after I select all the links on the page, and then how do I determine whether it's a valid link or it's a broken link.
So by definition, DevOps is a collaboration between the development and the operations team, which enables continuous delivery of application and services to the end users. So let's expand on this definition first. The development team is the one that actually produces the products. The operation team is related with the management or the maintenance of these products. Now there's a link that DevOps forms between these two teams, which makes this entire process much smoother. And this approach, this collaborative approach, is what's called DevOps. So DevOps focuses on continuous delivery of application, which means that when the development team is ready with the product, it immediately goes into the maintenance or the management phase, and it's then pushed on to the end users with minimum delay. Just in case you doubt the stand of DevOps today or its growth in the near future, you must know that according to the Information Week, DevOps will be in high demand for upcoming years and has no chance of slowing down. Also, according to LinkedIn, over the past few years, DevOps has increased in demand by 50%. Now that's quite a lot of growth. So clearly DevOps is a field that will be great to dive into and grow in. So before we begin how you can actually become a DevOps engineer, let's look at what we'll be going through in this video. First, we look at who is a DevOps engineer, followed by the DevOps career roadmap. We'll then look into a DevOps certification, and then finally the salary trends for a DevOps engineer. So who is a DevOps engineer? Now, a DevOps engineer is an IT professional who understands the software development lifecycle. And when I say software development lifecycle, I do not just mean the DevOps approach, but right from our waterfall model, which is our traditional software development lifecycle. And then, as you know, we moved on to the Agile, and finally we reached the DevOps lifecycle. So a DevOps engineer needs to understand the whole purpose of this lifecycle, why we had to move from one model to the other, what are the shortcomings that the previous models had, and what all does DevOps make up for. Also, other than understanding this entire process, they also need to know how to use the various automation tools for developing the continuous integration and continuous deployment pipelines. So of course, your next question must be, what is the continuous integration and continuous deployment pipeline? As you can see on your right, we have an image of this pipeline. So there are various stages. So first you have your planning stage where you plan things out and write an algorithm for your product. Then it's the building stage where the algorithm actually transforms into a code and is a product which could be used. Then you have the testing stage. In the testing stage, your product is tested, all the bugs are caught, and all of this is corrected. And once all of that's done, it's then sent to the deployment stage, which means now your product is ready to be deployed. Once it's deployed, of course, a product needs continuous monitoring. This is now something new which has been introduced in the DevOps lifecycle, that although your product is out in the monitoring stage is something that the DevOps approach focuses on much more than our previous models, and for very good reason, which is that once your product is deployed into the real world, to ensure customer satisfaction, it's important that you continuously monitor the product. This way you're able to catch the bugs, fix them, and push it back to the clients and ensure that they are happy with your product and would go for it again. Now, in simple words, a DevOps engineer is expected to collaborate with the developers and the operations team to deliver high quality products within a minimum amount of time. Now, DevOps engineer as such is not a profile that you might come across very often, but of course there are a number of career paths that you can take under the DevOps engineer. Some of these are the DevOps architect, automation engineer, software tester, integration specialist, security engineer, and release manager. Now let's look at the DevOps career roadmap. So basically, if you're looking forward to bagging that DevOps engineer job, where should you start and how should you go about it? First thing first, there are a few programming languages which go hand in hand with the DevOps tools. You need to pick up these and also know the Linux fundamentals. DevOps uses these programming languages for developing and automating software. Now, three most common languages used with the DevOps tools are Ruby, Python, and JavaScript. It is always advised that you know at least one of these. Of course, we must consider the fact that these three languages are used with completely different tools. So knowing just one of these languages does not mean that you can now work with any tool under the DevOps approach, but it does give you a good hang of at least one of them, which is more than most can say. It's also important to know the fundamentals of the Linux command line interface. Of course, this is not very unique to DevOps. Whichever career path you are choosing, Linux fundamentals is one of the most important things. Let's now discuss some of the mandatory Linux skills that a DevOps engineer should be aware of. The first is, of course, the Linux shell. Now, you must either know Bash or the kernel shell. Then the Linux commands. Now, there are a huge number of Linux commands, but the basic ones you must know no matter what are the find, grep, awk, and the set command. And finally, we have the networking commands, nslookup, which is for querying the DNS, and netstat for monitoring your connections. Our next milestone would be learning the source code management. Now, source code management is especially important when you're dealing with huge projects, so that all your codes, irrespective of the number of files you have or the number of versions of a particular code you have, everything is organized and can be easily accessible. So it's important that you're comfortable with at least one of these source code management tools. Here, the most common ones we see are Git, CVS, and Mercurial. I would personally recommend you to choose Git. And why Git? Because Git is used to track changes in the source code. It can manage large projects efficiently, and it allows multiple developers to work together with great ease. Now, our next stage is to learn to build applications. So a DevOps engineer must know how to build an application and commit to the source code management tools such as Git. Now, popular tool used to build applications, which makes things much simpler, is Maven. Why Maven? Well, it supports parallel builds, instant access to new features without any additional configuration, and has an easy build process. Now, Maven is actually an automation tool which helps to build and manage software projects within a short period of time. So here you have the POM file which is required to build an application, under which you have sets of jars. You have the commands which are to be executed, the builds, plugins, and the builds profile. But in order to automate the entire process, you require a continuous integration or a continuous development tool. And this brings us to our fourth stage, which is learning to automate the process using CI and CD tools. One of the most extensively used tools in this field is Jenkins. Jenkins is an open source continuous integration tool. It helps to automate continuous development, testing, and deployment of newly created codes. Well, why Jenkins? Because it has multiple plugins, it is easily distributed across multiple machines, and has an easy installation and configuration process. Our next stage is to learn to test the applications. Once you have completed the build process, learn how to automate the testing process of web applications. One of the best testing tools for QA teams is Selenium. And why Selenium above all the other tools that provide the same functionality? Well, because it provides fast execution, allows scripting in several languages, and also supports parallel test execution. The next thing is to learn to deploy applications in production servers. So you should learn how to deploy and run the applications in the production servers. And in order to deploy an application, you should have the knowledge of containers such as Docker and configuration management tools like Ansible. So Docker helps with the containerization, while configuration management tools such as Ansible. So Docker helps with containerization, while tools such as Ansible helps you to provide you the capability of pushing configurations onto multiple servers and maintaining them in the required state. So why choose Docker? High scalability and efficiency, reusable data volumes, isolated applications. And why Ansible? Because unlike other tools in this field, it has a push-based configuration. It is agentless and uses SSH for secure connections. The next stage is to learn to monitor the applications. So monitoring your applications is another important aspect of a DevOps engineer. In this stage, we identify the issue and implement the changes as quickly as possible. The most popular tool which provides for monitoring applications is Nagios. It has a comprehensive monitoring system, high availability, and immediate remediation. And finally, a DevOps engineer must know the working of cloud providers. For a DevOps engineer, it's important to know about the cloud service providers and their basics. Cloud computing is an important skill to learn irrespective of which field you're in today, as a lot of companies have the infrastructure on the cloud. Amazon Web Services is the most popular cloud provider, whereas Microsoft Azure and Google Cloud Platform are slowly catching up to Amazon. Amazon Web Services provides high scalability and flexibility, is cost effective, and provides better security. Let's now look at some of the DevOps certifications you can opt for. The first one is the AWS Certified DevOps Engineer program, which is offered by Amazon Web Services. And then, of course, we have the DevOps certification training offered by our very own Simplilearn. Simplilearn also provides programs which are more specific to tools such as Chef, Puppet, Ansible, and Selenium certification. And we also provide a DevOps Architect Master's program. So now these are some of the most popular certifications available in the market. Let's get a better idea of what these certifications provide. So we'll move on to the Simplilearn webpage. So here we are on the landing page for DevOps certification training course. As you can see here, this course provides 56 hours of in-depth learning. You will be working on more than 10 real industry projects which are integrated with the labs. There are 24 live demos of the most popular DevOps tools. You have a 24/7 support dedicated to mentor you throughout your project. And we also provide self-paced learning. So there are videos which are always available in case you have a very stringent timetable. Let's now look at some of the tools which are covered under this course. So under build automation, we cover Maven among other tools. Configuration management, there's Ansible, Chef, Puppet. Continuous integration and monitoring tools includes Jenkins, TeamCity, Docker, and testing frameworks. We have Eggplant, JUnit, version control, Bitbucket, Git. So we are going through a number of tools, but as you can see, all the popular ones are definitely covered. Other than this, let's also have a quick look at all the topics that is covered under this course. So we have the course introduction followed by introduction to DevOps, and then we focus on the various processes under DevOps: version control, continuous integration, deployment, and the build tools, software automation, testing frameworks, configuration management, containerization. All of this is followed up by need of cloud in DevOps, and of course you have practice projects. We also are provided with 2 free courses, one covering the Linux basics and one with the fundamentals of JavaScript. Since, as we have already mentioned, these are 2 very important skills that a DevOps engineer must possess. And now this is the DevOps Architect Master's program offered by Simplilearn. This is the go-to program if you take becoming a DevOps engineer seriously. As you can see here, guys, it covers more than 40 in-demand skills and 15 plus tools. You have access to 120 live instructor-led online classes. You'll also be working on more than 7 real-life projects, and at the end of your entire course, you receive your master's certification. There's a well-thought-out timeline to proceed with your course, which covers instructor-led and self-paced classes, your projects, and your lab sessions. Also, some of the tools that we'll be covering under this program include Maven, Chef, Puppet, Ansible, SaltStack, TeamCity, Jenkins, Nagios, JUnit, JIT, and many more. So guys, why procrastinate anymore? Get on to Simplilearn's webpage, register yourself to a course, and get certified, get ahead. Of course, if you're taking up a career, you must know what kind of salary to expect. An average salary of a DevOps engineer in the United States is $115,666 per year. So this is the average salary. As you can see here, guys, there's a graph which shows how there's been a growth. This graph here will give you a good idea of the salary trend. An average salary of a DevOps engineer in India, on the other hand, is 6,12,000 per year. So again, here we have a graph on the right which demonstrates the pattern in growth in the salary?
So there are approximately 7 sections that we cover in DevOps. We go from general DevOps questions, source code management with tools such as Git, continuous integration, and here we'll focus on Jenkins, continuous testing with tools such as Selenium, and then you also have the operations side of DevOps, which is your configuration management with tools such as Chef, Puppet, and Ansible, containerization with Docker, and then continuous monitoring with tools such as Nagios. The first video is going to zero in on the left-hand side of the screen. We're going to zero in on those general DevOps questions, source code management, continuous integration, and then continuous testing. Our second video is going to get into the operations tools, and we'll get into that the next time you come back. Above me, there's probably a link that will take you straight to that video. So let's just get into those general DevOps questions. So one of the questions that you're going to be asked is, how is DevOps different from Agile? And the reality is that DevOps is a cultural way of being able to deliver solutions that's different from Agile. If we look at the evolution of delivery over the last 5 to 10 years, we've gone from waterfall based delivery to Agile delivery, which is on sprints, to where we are with continuous integration and continuous delivery around DevOps. The whole concept of DevOps is culturally very, very different from Agile. And the difference is that you're looking at being able to do continuous releases. What does that mean? The difference is that you want to be able to send out code continuously to your production environment. That means the operations team, the development team have to be working together. That means that any code that gets created has to be able to go to production very quickly, which means you need to be testing your code continuously, and then that production environment must also be able to be tested continuously, and any changes or any errors that come up have to be communicated effectively and efficiently back to the dev and op team. Another area in which I see that DevOps is different is really the response that we have for how we engage with the customer. So the customer is coming to your website, to your mobile app, to your chatbot, or any digital solution that you have, and has an expectation. When you're going through and actually doing a DevOps paradigm, the old model would be that you would capture requirements from the customer, then you do your development, then you do your testing, and there would be these barriers between each of those. As we move faster through from waterfall to Agile, what we saw is that with Agile, we were able to respond much faster to customer demands. So instead of it being weeks or months, sometimes in some cases years between releases of software, what we saw was a transition to weeks and months for releases on software. Now we see with DevOps is that the release cycle has shrunk even further with the goal of continuously delighting the customer. How further has that release cycle shrunk to? There are companies that have gone from having releases of once a week or once every 2 weeks or once a month to now having multiple releases a day. Indeed, some companies have up to 50 releases a day. This isn't something to also bear in mind is that each of those releases are tested and verified against test records so that you can guarantee that the code that's going to production is going to be good continuous code. So what are the differences between the different phases of DevOps? So effectively, there are 2 main phases of DevOps. There's the planning and coding phase, and then there's the deploying phase. And you have a tool such as Jenkins that allows you to integrate between both environments. Some of the core benefits that you may have to DevOps are going to be some technical benefits and some business benefits. So when somebody asks you what are the benefits of DevOps, you can reply that from a technical point of view, you're able to use continuous software delivery to constantly push out code that has been tested and verified against scripts that have been written and approved. You can be able to push out smaller chunks of code so that when you have an issue, you're not having to go through massive blocks of code or massive projects. You're going through just very small microservices or small sections of code, and you're able to detect and correct problems faster. On the business side, the benefits are absolutely fantastic. From a customer that's coming to your website or to your mobile app, they're going to see responses happening continuously so that the customer is always aware that you as a company are listening to their demands and responding appropriately. You're able to provide a more stable environment, and you're able to scale that environment to the demands of the number of customers that are using your services. So how will you approach a project that needs to implement DevOps? So this is really an exciting area for you to be in. So there are effectively 3 stages when it comes to actually working in a DevOps. The first stage is an assessment stage, and think of this as the back of the napkin ideation stage. This is where you are sitting with a business leader and they're giving you ideas of what they would like to see from feedback that they've had from their customers. This is blue sky opportunity. This is thinking of big ideas. That second stage, and this often comes as a fast follow to stage 1, is actually proving out that concept. So developing a proof of concept. And a proof of concept can actually be multiple different things. So it could be something as simple as a wireframe, or it could be something that is as complex as a mini version of the final application. Depending on the scope of the work that you're delivering will really depend on how complicated you want the POC to be. But with that in mind, whatever choice you make, you have to be able to deliver enough in the POC so that when you present this to a customer, they're able to respond to that creation that you've developed and able to give you feedback to be able to validate that you are going with the right solution and able to provide the right product to your customers. That third stage is where you get into your DevOps stage, and this is just the exciting part. This is where the rubber hits the road and you start releasing code based on a backlog of features that are being requested for the solution. In contrast to doing agile delivery where you just continuously work through a backlog, with DevOps, what you're also looking at is putting in analytics and sensors to be able to validate that you are being successful with the solution that's being delivered. So that once you actually start delivering out code that customers can interact with, you want to be able to see what are the pieces of the solution that they are using, what do they like, what is complicated, where are the failure points, and you want to use that data and feed that back into your continuous integration and have that as a means to be able to backfill the demand of work that gets completed in the backlog. So what is the difference between continuous delivery and continuous deployment? So continuous delivery is based on putting out code that can be deployed safely to production. It ensures that your businesses and functions are running as you would expect them to be. So it's going through and completing the code that you'd actually see. Continuous deployment, in contrast, is all about ensuring that you're automating the deployment of a production environment. So you're able to go through and scale up your environment to meet the demands of both the solution and the customer. This makes software development and release processes much more faster and more robust. So if we look here, we can actually see where continuous integration and continuous deployment come hand in hand. So when you actually start out with the initial pushes of your code, that's where you're doing your continuous integration and your continuous delivery. And then at some point, you want to get very comfortable with deploying the code that you're creating so that it's being pushed out to your production environment. One of the things that's great about working with the tools that you use in a DevOps continuous integration and continuous delivery model is that the development tools that you use, the containerization tools, the testing tools, should always reflect the production environment. And what this means is that when you actually come to deploying solutions to production, there are no surprises because your development team have been working against that exact same environment all the way through. So a question that you'll also be asked is, what is the role of the configuration management in DevOps? And so the role of configuration management really has 3 distinct areas. The first, and this is really the obvious one, and this is the one where you probably already have significant experiences, is the ability to manage and handle large changes to multiple systems in seconds rather than days, hours, or weeks, as may have happened before. The second area is that you want to also demonstrate the business reasons for having configuration management. And the business reason here is that it allows IT and infrastructure to standardize on resource configurations. And this has a benefit in that you're able to do more with fewer people. So instead of having a large configuration team, you can actually have a smaller, more highly skilled team that's able to actually manage an even larger operational environment. And thirdly, you want to be able to highlight the ability to scale. So if you have configuration management tools, you're able to manage a significant number of servers and domains that may have multiple servers in. It allows you to effectively manage servers that are deployed on cloud or private cloud and allow you to do this with high accuracy. So how does continuous monitoring help in maintain the entire architecture of the system? So when this question comes up, you want to dig in and show your knowledge on how configuration and continuous monitoring is able to control an entire environment. So the number one topic that you want to bring up when it comes to continuous monitoring is that with being able to effectively monitor your entire network 24/7 for any changes as they happen, you're able to identify and report those faults or threats immediately and respond immediately for your entire network instead of having to wait, as it happens sometimes, for a customer to email or call you and say, hey, your website's down. Nobody wants that. That's an embarrassing thing. The other three areas that you want to be able to highlight are the ability to be able to ensure that the right software and the right services are running on the right resources. That's your number one takeaway that you want to be able to give of continuous monitoring. The second is to be able to monitor the status of those servers continuously. This is not requiring manually monitoring, but having an agent that's monitoring those servers continuously. And then the third is that by scripting out and continuously monitoring your entire environment, you're creating a self-audit trail that you can take back and demonstrate the effectiveness of the operations environment that you are providing. So one of the cloud companies that is a strong advocate for DevOps is Amazon's Web Services, AWS, and they have really 5 distinct areas that you can zero in on for services. So when the question comes up, what is the role of AWS in DevOps? You want to really hold out your hand and list off 5 areas of focus using your thumb and finger. So you want to have flexible services, built for scale, automation, secure, and a large partner ecosystem. And having those 5 areas will really be able to help demonstrate why you believe that AWS and other cloud providers, but AWS is certainly the leader in this space, are great for being able to provide support for the role of DevOps. So one of the things that we want to be able to do effectively when we're releasing any kind of solution is to be able to measure that solution. And so KPIs are very important. So you will be asked for 3 important DevOps KPIs. And so 3 that really come to mind that are very effective. The first one is mean time to failure recovery. And what this talks about is what is the average time does it take to recover from a failure? And if you have experience doing this, then look at the experience that you have and use a specific example where you are able to demonstrate that mean time to failure recovery. The second is deployment frequency. And with deployment frequency, you want to be able to discuss how often do you actually deploy solutions and what actually happens when you're actually doing those deployments and what does the impact to your network look like when you're doing those deployments. And then the third one is really tied to that deployment frequency, which is around what is the percentage of failed deployments. So how many times did you deploy to a server and something happened where the server itself failed? What we're looking for when you're going through and being asked for these KPIs is experience with actually doing a DevOps deployment and being able to understand what DevOps looks like when you're pushing out your infrastructure. And then the second is being able to validate that self-auditing ability. And one word of caution is don't go in there and say that you have 100% success. The reality is that servers do degrade over time. And you maybe want to talk about a time when a server did degrade in your environment and use that as a story for how you were able to successfully get over and solve that degradation. So One of the terms that is very popular at the moment is infrastructure as code. And so you're going to be asked to explain infrastructure as code. And really, it's something that actually becomes a byproduct of the work you have to do when you're actually putting together your DevOps environment. And infrastructure as code really refers to the writing of code to actually manage your environment. And you can go through many of the other tools that we've covered in this series, but you'll see that XML or Ruby or YAML are used as languages to describe the configuration for your environment. This allows you to then create the rules and instructions that can be read by the machines that are actually setting up the physical hardware versus a traditional model, which is having software and installing that software directly onto the machine. This is really important when it comes to cloud computing. There really is a strong emphasis of being able to explain infrastructure as a service, and infrastructure as code is fundamental to the foundation to infrastructure as service. And then finally, it allows you to be able to talk about how you can use scripted languages such as YAML to be able to create a consistent experience for your entire network. All right, so let's now get into the next section, which is source code management. And we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application, and if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model, actually we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have four options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as GitLab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way, using git init, allows you to create a working directory using the command git init, and then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, using the bare way, you have a different commands for setting that up. So it would be git init --bare, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are two ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 560E0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are two ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you want to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is, what is a Git stash? So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side, what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that, and that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git? And how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in, and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially 4 stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. And that will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved. And then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. You will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into GitHub, and this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with the command line you want to use git bash, and so you want to, as a first step, open up git bash and then navigate to the local git repository in command line using the cd change directory, and then list out the actual folder where you actually are putting all of your code. And then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor. But as you go through and edit out what you want to keep and what you want to manage in your conflict, so you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository. All right, let's talk about the next section, which is continuous integration with Jenkins. So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository such as GitHub and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for three distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline, and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as the domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. A question you'll be asked as well is, how can you copy Jenkins from one server to another? Well, there are 3 ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. There are 3 ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the 3 responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins home plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom built plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled, allowing you to make your administrative changes and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled or run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent on each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build a environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart. So let's go into the 4th and final section of this first video, which talks about continuous testing with Selenium. So the first question you will be asked most likely around Selenium are, what are the 4 different Selenium components? And again, you will want to hold open your fingers because there are 4 distinct environments. You have Selenium Integrated Development Environment, or Selenium IDE. You have Selenium Remote Control, or Selenium RC. You have Selenium WebDriver, and then Selenium Grid. You'll be asked to explain each of those areas in more detail, but let's start off by looking at Selenium Driver. What are the different exceptions in Selenium WebDriver? So it's useful to remember that an exception is an event that occurs during the execution of a program that disrupts the normal flow of that program's instructions. And so we have 4. We have a timeout exception, an element not visible exception, no such element exception, and a session not found exception. And each of those, if we step through them, are the 4 different types of exceptions that can be thrown up when using the Selenium WebDriver. So as we evolve in our digital world with the different types of products that are available for us to be able to build solutions onto multiple platforms, you're going to be asked, can Selenium and other DevOps tools run in other environments? And so a good question around this is, can Selenium test an application in an Android web browser? And the short answer is absolutely yes, it can. But you have to use the Android driver for it to be able to work. So you want to be able to talk about the 3 different types of supported test within Selenium. So when the question comes up, what are the different test types supported by Selenium, you can answer it. And there are 3 different types of test. First is a functional test. Second is a regression test, and third is a load testing test. The functional test is a kind of black box testing in which test cases are based on a specific area or feature within the software. A regression test helps you find any specific areas that functional tests or non-functional areas of the code wouldn't be able to detect. The load testing test allows you to monitor the response of a solution as you increase the volume of hits in how you're using the code are put onto it. An additional question you'll be asked is, how can you get a text of a web element using Selenium? Well, the get command is used to retrieve text of a specific web element. It's important to remember, however, that the command does not return any parameters, but just returns a string value. So you want to be able to capture that string value and discuss about it. A question you'll be asked around Selenium is, can you handle keyboard and mouse actions using Selenium? And the answer is yes, you can, but you have to make sure that you're using the Advanced User Interaction API. And the Advanced User Interaction API is something that can be scripted into your tests, and it allows you for capturing methods such as a click and hold and drag and drop mouse events, and then keyboard down or keyboard up key release events, so that if you want to capture, say, the use of Control Shift or a specific function button off the keyboard, you'd be able to capture those. Of the following four elements, which of these elements is not a web element method? A, get text, B, size, C, get tag name, D, send keys. And it's B, size. You're going to be asked to explain what is the difference for when we use find element or find elements. And so if we look at find element finds the first element in the current web page that matches the specified locator value. In contrast, find element finds all of the elements on the web page that matches the specified value. When using WebDriver, what are the driver close and driver quit commands? And these are two different methods used to close a web browser session in Selenium. So driver close will close the current web browser on which your focus is set, and driver quit closes all the browser windows and ends the WebDriver session completely. The final question that you are likely to be asked in using Selenium is, how can you submit a form using Selenium? Well, in this instance, that's relatively easy. The following lines of code will let you submit a form in Selenium, which would be web element el equals driver.findElement, and then you put in the ID and the element ID, and then l submit, open close parentheses, semicolon. So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is hashtag systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively, and one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do what is the command to sign a requested certificate, the top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the three options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the three tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are four. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture. So let's get on to our next section, which is containerization. So let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms, and then finally, for space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution part that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes. Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the Compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you can be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is you want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked how to create a Docker container. So let's go through what that would look, and we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, for the registry, we have Docker registry is an open source server-side service used for hosting and distributing Docker images, whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry, and it has two types, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace, but you could add in there IBM, Bluemix. You could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker? So if we go through, expose is an instruction used in Docker file, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these are expose 8080, or with Docker, we would put in, or for publish, we would do the example Docker run -d-p and then 0.0.0.80, 80:80 as our command line. So let's look at continuous monitoring. So with continuous monitoring, how does Nagios help in continuous monitoring of systems, applications, and servers? And so this is really just a high-level question of using Nagios within your environment. And you should be able to just come back very quickly and say, Nagios allows you to help manage the servers and check if they're being sufficiently utilized and if there are any task failures that need to be addressed. And so there are 3 areas of utilization and risk that you want to be able to manage. This is being able to verify the status and services of the entire network, the health of your infrastructure as a whole, and if applications are working properly together with web services and APIs that are reachable. So the second question you'll be asked is, how does Nagios help in continuous monitoring of systems, applications, and services? So it's able to do this by having the initial Nagios process and scheduler and the additional plugins that you would use for your network connect with the remote resources and the Nagios web interface to be able to run status checks on a predefined schedule. So what do you mean by Nagios Remote Plugin Executor, or the NPRE of Nagios? So NPRE allows you to execute plugins on Linux Unix machines that allow you to do additional monitoring and machine metrics such as disk usage, CPU load, etc. What are the ports used by Nagios for monitoring purposes? In this example, there are 3, and they're easy to remember, so I would memorize these 3, but they're essentially ports 5666, 5667, and 5668. So there are 2 types of checks within Nagios. So you will be asked for what is an active and passive check in Nagios. So an active check is initiated by the Nagios process and is run on a regular schedule. A passive check is initiated and formed by an external application or process. So this may be where a system is failing. And results are submitted to Nagios for processing. And to continue with this, for what is an active and passive check, active checks are initiated by the check logic within the Nagios daemon. Nagios will execute a plugin and pass information about what needs to be checked. Plugin will then check the operational state of the host or service and then process the results of the host or service check and send out notifications. In contrast with the passive check, it is an external application that initiates the check. It writes the results of the check to an external command line file. Nagios reads the external command file and places the results of all passive checks in a queue for later processing, so you can go back and revalidate. And then Nagios may send out notifications, log alerts, etc., depending on the results that they get from checking the information. So you're going to be asked to explain the main configuration file and its location in Nagios. So the main configuration file consists of a number of directives that affect how Nagios operates. So consider this as the configuration file that it's read by both Nagios processor and the CGIs. So this will allow you to be able to manage the main configuration file that's placed into your settings directory. So what is the Nagios Network Analyzer? And again, hold out your 4 fingers because there are 4 options here. So the Nagios Network Analyzer 1 provides an in-depth look at all your network traffic source and security threats. 2 allows system admins to gather high-level information on the health of your network. 3 provides a central view of your network traffic and bandwidth data. And then 4 allows you to be proactive in resolving outages, abnormal behavior, and threats before they affect critical business processes. So what are the benefits of HTTP and SSL certificate monitoring with Nagios? So with HTTP certificate monitoring, it allows you to have increased server and services and application availability, obviously very important, fast detection of network outages and protocol failures, and allows web transaction and web service performance monitoring. The SSL certificate monitoring allows you for increased website availability, frequent application availability, and provides increased security. So explain virtualization with Nagios. So in response to this, the first thing you should be able to talk about is how Nagios itself can run on many different virtualization platforms, including Microsoft Visual PC, VMware, Xen, Amazon EC2, etc., etc. So just make sure you get that right off the bat. Nagios is able to provide capabilities to monitor an assortment of metrics on different platforms. It allows for quick detection of service and application failures, and has the ability to be able to monitor against many metrics, including CPU usage, memory, networking, and VM status. So name the 3 variables that affect recursion inheritance in Nagios, and it is name, use, and register. So name is a template name that can be referenced in other object definitions. Use specifies the name of the template object that you want to inherit its properties and variables from. And register indicates whether or not the object definition should be registered to Nagios. And on the right hand side of the screen we have an example of what that script would look like. Again, you may want to be able to memorize this, as it's something that you can actually write down and show someone if you're going through a technical interview. So why is Nagios said to be object-oriented? And fundamentally it comes down to the object configuration format that you can use in your object definitions. It allows you to inherit properties from other object definitions, and this is typical of object-oriented development and is now applied for the Nagios environment. So some of the objects that you can inherit are services, host, commands, and time periods. So finally, explain what is state talking in Nagios. And so there are really 4 options here when you're talking about state stalking. So state stalking is used for logging purposes in Nagios. It allows you to enable for a particular host or service that Nagios will watch over very carefully. It will log any changes it sees in the output of the check results. And then finally helps the analysis of log files.
Well, this was all about DevOps Advanced Full Course. I hope you found this video informative and interesting. If you like this video, then please give it a thumbs up and share it with your friends. Also, if you have any questions, then please feel free to ask away in the comment section. Our team will reach out to you as soon as possible. Thanks for watching and keep learning.
More.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.